Okay. Good morning. Welcome to our headquarters of Seaman Europa here in Nigran at Porto Mole. From here, we're gonna give to all distributors in Europe the training session for the FMF Series echosounders. Training objectives are going to be the following. We want the distributors to be able to advise the client on the correct selection of the equipment suited to the specific needs of the client. So this is not going to be only a technical presentation, but it's going to mixture some commercial, if you want to say it, aspects. We want to be sure that all the technicians that carry out our equipment are able to carry out the installation in a successful manner. And this includes the transducer, the black box, and CPU. The goal here is to know how is the ideal installation. We know that in real life, the ideal installation not always possible, but we want to enforce the need for a proper installation, because that's where the problem begins. Carry out an initial setup and configuration is also one of the objectives of this presentation. Be able to assist the operator about the interpretation of the information on the screen. So not only the adjustment, but how to read the echosounder properly, how to understand all the indicators that you have in the echosounder. Especially focus on the size measurement tool, which is a very important tool in this echosounder, and not always well understood, because this is a source of many confusion, the size measurement, especially in the limits of the technology. What can be done and what cannot be done with the size measurement technology. Then we are going to put the focus on the problems and failures that you can find during the use of the echosounder and the normal operation. And we want the technician to be able to differentiate an operation problem from a technical problem. That is, if it's an understanding problem from the skipper, or it's a real technical problem. Sometimes it's not clear. The training schedule, we will have 2 days of training. Day 1 is today. In day 1, we're gonna go through the all aspects of the description of the FMF and FMF-1000 and FMF-900 echosounders. We're going to do a little comparison in between our echosounders and competitors' echosounders in the main aspects. We're going to talk about the installation in the first block. Then we're going to have a coffee break. And after the coffee break, we are going to talk about troubleshooting, all the problems that you can encounter, mainly because of not ideal installation. After that, after the lunch break, we're going to go through all the hardware issues. We're going to make a description of the parts of the system. We're going to look at it. And we're going to go through the firmware and software upgrade process also. Day 2 is the day for talking about size measurement. And here we're going to go in detail how the echosounder measures and what is the thing with the species and all the details related with TS calculation and conversion to centimeters. And then finally, after the coffee break tomorrow is going to be a half day. I know you have, some of you have to leave in the evening, so we're gonna try to be on schedule. So it's gonna be a period for questions of the entire presentation, not only the day 2, but if you have some question pending from the day 1, you will be able to do it. Okay, first slide. Well, this is something every manufacturer of the equipment says about their own equipment. My equipment is the most important one in the fishing vessel. Okay, but this is true. In a fishing vessel, the detection equipment is the most important equipment on board. So I know all of you have to deal with different types of equipment. You are not like only acoustic specialists, so you have to deal with navigational, communicational equipment, but the acoustic devices are very important for the skipper. So the technician will have to be able to give assistance to the skipper, not only the operation of the equipment, but understanding how to read and interpret, have a good interpretation of the information on the screen. So it's not only like being a human user manual. It's like understanding what is going on the screen and being able to explain the skipper really what he can do and what he cannot do with the equipment. Okay. Well, we're gonna start describing our family of echosounders. Right now, in the FMF family, we have 2 models, FMF-1000 and 900. The difference between each other is very simple. 900 has 2 channels. 1000 has 4 channels. That's the only difference from the hardware perspective. The firmware, however, is different between the FMF-1000 and 900, because the FMF-1000 is a sounder that can be able to be configured in split beam mode. That is not the case for the 900. So the 900 is gonna be a dual beam echosounder, and the FMF-1000 is gonna be a split beam ready echosounder. So both can do a size measurement, but with using different technologies and different principles of working. Here you see a schematic layout of the 900 echosounder. You see that when we provide the echosounder, we provide it with a PC normally, which is an industrial grade PC. A trackball is also provided as a standard equipment. It's essential to use and operate the echosounder because our echosounder has no keyboard, so it's all the commands you do it with the trackball. And then there is a junction box that is connected to the black box. This junction box allows you to interconnect all the transducers and to synchronize with other equipment and connect external sensors to the, you will see it, we'll go through that in detail during the presentation, but you can connect the trigger out and you can connect power to the junction box and transducers. Then to the PC, it's going to be connected all the external devices like external sources of information like Marport or Time Zero, where you can export information. other navigational equipment like the equipment that provides GPS position to the sounder, and having compensation in the case of satellite compass. You can provide the equipment with the information of having compensation to adjust the button, not to see the bumpy button you see when you don't have this feature available. 900 is able to use 2 screens, so you can not only use one but 2 separate, operated as one. So if you have 2 channels, you can have 1 channel in each screen, so it's going to be like having 2 echosounders in one. FMF-1000 is very similar schematic. The only difference is the number of channels available with the echosounder. Here, you see in the picture, you see 4 transducers. Actually, it can be 4 transducers or can be 1 split beam transducer with 4 sectors. So that is the CPU requirements. These are actually not minimum but suggested requirements for the CPU, because 900 can use a less performance CPU, but this is a suggested configuration of the CPU in case you don't buy the CPU from us. We provide the 1000, we use CPUs from external manufacturer, it's called Nexcom. So we provide the FMF-1000 with a CPU, the model is NICE 3900, and the FMF-900 uses a little smaller CPU because it's not going to be using split beam, so the demands of the computational demands are lower. So it uses a CPU from Nexcom, the NICE 109. Today, all the equipment that you have, pretty much all the equipment that you have in market is black box. But I want to remember some of the advantage of being black box, and but I'm going to stress the point of being black box in case of the FMF family. We have another advantage, for example, when compared with Furuno units, particularly the 1900, it carries the transceiver and the CPU all in one box. In our case, we have CPU and transceiver separated. So this is an advantage because you can locate the transceiver in a different location. You can put install the transceiver in a different location, I'm sorry, in the VSIL. And that we will see further in the presentation. That will help to avoid noises and interferences on board. So that's an advantage. With our sounder, like in Simrad case, you can put the transceiver at the end of the transducer cable, and then you can cable up with an Ethernet cable and locate the CPU in the wheelhouse. With Furuno, you have to splice the transducer cable, and that's always a source of problems and noises. And that's, I want to say that's an advantage. The other advantage is that you can use, this is CPU flexible. So you can use different types of CPUs, and you can improve the system performance by improving the performance of the CPU. So actually, with the CPU that we provide, the system will perform 100%. But if you have a better CPU, then the system will be much better. Like especially when we are going deeper, we are going deeper, that we have more data to process, and then a bigger water column. Then you will see some performance improvement by improving the CPU. So the CPU is separate, it has this advantage. So you can use different types of CPU, and you can also improve the performance. You can use, with black box system, you can use different types of screen. You know that fishing vessels are not like military or merchant ships that always use these marine grade screens. Sometimes they use PC screens, sometimes they use the screen they have available. So with these echosounders being based on a PC, you can do that. I want to add one thing to this is that when you have and this is very important, when you have a black box CPU based echosounder, you also have the possibility to remote control the echosounder. And that's today is a big advantage. It's one of the our main strengths to is to have direct contact with the echosounder on board while the skipper is fishing. So that is a huge advantage for support when the fisherman is fishing. So that's another advantage of having a CPU-based black box system. This is a comparative chart where we see some main aspects of the sorry, I'm going to move because I want to see. Here you have a comparison between the FMF, the S80, and the FCB-1900G. I use, in the case of Furuno, I use the G, which is the top of the line of the 1900 echosounder. Of course, from Furuno, there are other echosounders split beam like the FCB-38. But I put these three because I wanted to do the comparison, because FMF-900 is the one we try to compare with the 1900 from Furuno, and the S80 is the one we like to compare in the market with the FMF-1000. So here you see in frequency range, we are at the same level, at the same values with Simrad. Our system works from 10 to 500 kilohertz. In case of Furuno, the system goes from 28 to 250, which is okay because it covers all the frequencies that we usually use in the fishing market. The only thing that I will say is that my experience is when I've been in Japan, some applications of the echosounder, especially in very low depths and with high resolution demands. For example, they fish for little fish they call baby anchovy. It's a 3 centimeters long fish, and they demand this resolution that they want to see this 3 centimeter fish, but also they want to separate this fish from a 5 centimeter fish, which is not a target species. So it's very demanding. For that kind of application, having the limit of 250 kilohertz is you will need a higher frequency to reach that kind of resolution, or using chirp mode. Using chirp mode, you have also good resolution. So that I don't see a big difference. In the case of bandwidth, there is a difference. We are at the same values with Simrad, but we have a double bandwidth compared with Furuno. And Furuno puts you a limit of bandwidth when you use chirp mode of 50 kilohertz. In our case, you can use 100 kilohertz. Remember that bandwidth in chirp mode is what provides resolution. The wider the band of frequencies you use, the more resolution, the more vertical resolution you will have. So it's not the same having 50 kilohertz or 100. It's having 100 kilohertz is a very good advantage. The third parameter is the power per channel. Our sounder is specified for 3 kilowatts or 3,000 watts per channel. That is in CW mode. In chirp mode, the limit is 2,000 watts. Simrad echosounder is 500 watts per channel. There's a reason for that, and I will go through in a moment. Furuno 1900 is 3 kilowatts also. It's like our sounder in that parameter. The reason why Simrad, this is my guessing, I don't know for sure because I didn't read anything official about this on Simrad, but my guessing is that when the ES80 was started being developed in 2008, what Simrad engineers decided is that they were going to do an FM, like a chirp echosounder, wideband echosounder. So when they started specifying the equipment, I guess, they must be thinking about an echosounder operating only in chirp mode. They never imagined that that echosounder will be used in CW. Because when you use chirp mode, you rely on bandwidth and pulse length more than the actual physical total power output that the system has. So if you have a good bandwidth equipment, you can do a long pulse in chirp. You will have enough energy on the water that on the minds of the designers at that time was okay, because if you have let's say a pulse of 8 milliseconds, then you are going to put in on the water a lot of energy. You don't need a big equipment with a lot of power that then is a heat source. Then you have to treat the heat on the equipment. There's a challenge of engineering to get rid of that heat on the echosounder. So I guess they decided to make a lower power equipment. The ES60 was 1 kilowatt per channel. But the problem this created was that many installation with Simrad was performed using legacy transducers from Simrad. They used transducers narrowband, like the ES38B or the Combi. But those transducers were CW transducers. So the ES80 was forced to use in CW mode, which was not designed for. So the challenge was it has very low output power, 500 watts. Now you're using your echosounder half power that when you were using with the ES60, but that's not the only problem. Since you have a chirp echosounder, the receiver is like wide open. So now you don't have like the electronics that you used to have in the ES60, those filter stages that you used to have in the ES60. Now you have an open receiver. You have to treat all that signal digitally, and then you have low output power. In the CW world, that's a bad equation. Like low output power, a lot of noise coming into the receiver, so the result was not good. So some of the first implementation of the ES80 being used with legacy existing transducers ended up in a client calling Seaman for DBF in that moment, and replacing the ES80 for a DBF, which was something that you can use 1 kilowatt per channel in CW. So that I see as an advantage for us. If we work, especially if we work in CW world. Um, all equipment in this list carry out the roughness and hardness, with the only exception of the roughness in Simrad is not available like it is available in our echosounder and Furuno. The hardness, it is available in Simrad, but they have a roughness indicator, but I cannot understand it to be true. The FMF and the S80 can do biomass, can produce a biomass index. It's not the case in the Furuno. That the biomass index is sometimes could be a tricky, but sometimes could be a very important piece of information for the skipper, especially when they adjust, lower the screen gain. Because some skippers, you know, they don't like to see many so much information on screen, so they adjust the gain low. Since it, yeah. I know. So when that happens, it might be the case that sometimes fish very close to the bottom, you can not see it, you can lose it. But if you have the biomass index active, then you will have like an alert. Something big is getting into the expander, and that works fine. It's not something, some skippers told us that you could do some relation in between the NASC, which is the index that we use for biomass, the same index that Simrad uses, NASC, is like. This is stands for nautical area scattering coefficient. This is like taking the SB, which is the SB is the total backscattering of all the show. So it's the signal that you have from one fish show completely. When you insonify one fish show, then the value you receive is called SB. But then you take this SB and you put volume to it. And you give the, mathematically, you add the volume. So it's like in the US, so in the US, Simrad call it BI, biomass index. But the skippers in the Pacific Northwestern Fleet, I know, they call it the bullshit index. Okay? So, and this is true because it's totally bullshit. But what they use it for is when that number rises up very suddenly, then something, and you compare yourself with your transducer adjusted like your transducer, you compare different shows in the screen, then you know this one is has more biomass on it than the other. You cannot precisely make a relationship from the biomass index to fish quantities unless you do some research in your own vessel, like you record one catch and then you see what you catch, and then you convert that. You see the biomass number and you convert that to fish tons or kilograms. But this is something that it's widely used in the scientific community because this is used for calculating the catching quotas because this works in fish aggregations. In case of fishermen, to use it live is very tricky, but it's a tool that we have, Simrad have, Furuno doesn't. Our sounder and the S80 is capable of doing acoustic signature. Some of you we've seen at the Navalia, so you had the chance to operate the system that we have in our stand, and there you saw the acoustic signature working. I think that having acoustic signature is a huge advantage when compared with Furuno, because you have the key to species identification. In case of Furuno, they will be in trouble to do it in the 1900 because they don't have the computational power to do it in the echosounder. They will need to use some external devices if they want to. Our sounder is able to store data, raw data, and is able to do playback. Also the S80, the 900 is that cross is not completely right because they can record data, but not the same way that we and Simrad can do it. It's like you record like a video in the Furuno. You cannot reprocess data the way we reprocess data in the sounder, and also in Simrad. In Simrad and in Seaman echosounder, you can replay the history files, and you can reprocess, meaning that you can readjust the gain or TVG or all parameters that are graphic post-processing parameters can be adjusted in a history reproduction, in raw data reproduction. Pulse width in Simrad and our echosounder is maximum 8 milliseconds. In Furuno is limited to 5 milliseconds. Pulse width is very important when you're using chirp mode because chirp is a correlation. So correlations have the effect, they work like a noise filter. So the longer the correlation lasts in time, the more noise that the equipment will be able to filter from the correlation itself. So you can have filters, but in chirp echosounders, since you have a big receiver open, then the filter, all the filter is gonna be digital. So the correlation is gonna be very important for not only for making the echo, producing the echo on screen, but also for filtering noise, because noise does not correlate. So this is having a long pulse, having different, we experience in practice that changing in between pulse lengths have a strong effect in the noise you see on screen. This is a technical aspect, modulation of the pulse when you use FM pulse, I'm sorry. We are the same. Split beam compatible, we are now referring to the FMF-1000. Split beam is able to do in FMF and in ES80, not in the 1900. The black box layout I put across in the FCD 1900 because it's not, to my understanding, it's not fully black box because it's you cannot split the CPU from the transceiver, so it's only one unit, and you have to use a keyboard to operate it. It's little less black box than the ES80 or the FMF. Dual beam compatible, the FMF-900 is dual beam compatible, the ES80 is not. The FCB is dual beam. Users. In this family, the FMF family, we introduce new feature that is the user, the capability of recording, the capability of creating users and storing all the adjustment and settings that you are going to use. This is a very strong tool. It's very important because you can not only store your preference, your settings, but you can store like settings for different seasons, and you can store different types of fishing settings. So it's very powerful and very easy to use. It's like you're using it, you adjust it, you create a new user. Okay, I'm bottom fishing. Okay, bottom fishing in Svalbard. Store it. And you can create and store as many users as you want. This feature is available in our sounder, Seaman sounder. It's not available in Furuno system. Comparative advantages of the FMF system. We can use one of our strongest points of selling when you're offering the FMF system, not only for selling but for trials, is the ability to use legacy or existing transducers on board. Our sounder is designed to do it. It's not that happens by coincidence. It's something engineered for that. Our sounder, you will see when we go through the hardware that our sounder is has like an antenna coupler built in. So it will adjust the impedance to match the proper layer on the transformer. So that feature makes our sounder able to match different transducer with different impedance values. So that is the reason why we can use existing transducers, but we don't only match the impedance of the transducer, we also check the amount of voltage that the transducer can absorb, and that helps to not damage the transducer if the transducer is a little worn out. It's all the transducers are mechanical parts. So with the use, they have a normal worn out. So in this FMF family, we improved the history, reproduction, and recording, and we added the playback function. You will see that we have a tool in which you can easily move back the screen and see things that maybe you were looking at the screen and you missed one piece of information, and you can easily go back and move to live when you want. So that feature of playback function is very strong. You can store tons of screens. I don't know how many, 50? Maybe 50 screens. So it's very powerful. So you can go back like 50 screens in full HD. So it's a lot of information. Well, the black box concept, we've been through that a lot. The transmitting power, our sounder has that ability that you can add channels, and you can use the echosounder, like you can add 2 or the 4 channels if you want. And you can use the echosounder as it's one transceiver. So this is very important when you're replacing legacy. When you're using legacy transducer like those high power transducers from Furuno, 5 kilowatts or 10 kilowatt transducer. Today, there's not so much equipment available that can use that transducers with high power transmission. And this is very important for very, very deep application. They are bottom looking sounders mostly, but it is still a lot of equipment in the market that has, for example, it was an echosounder from Furuno, the FCB 1500. You remember? Okay, that came with a special unit that power amplifier to use these large transducers in CW. We can replace that by using our system adding channels. Graphic user interface is very intuitive. I would like to say it's easier than the Furuno interface, for sure. It's very similar to the SIMRED interface. We try to, whenever we design the equipment, it's not that we like copycat the systems, but we try to give the user the sensation that the user is looking at a familiar screen. It's not like something new that he has to get used to. The users tool is the other feature that we added with the FMF family, which is a very, very important tool. How do I recommend the right echosounder to my client? That's a question that I received many times. What type of echosounder do you recommend for that type of fishing visit? Main difference in between the FMF, the 1000 has 4 channels, 3 kilowatt each. The 900 had 2 channels. The 1000 is split beam ready. The 900 is dual beam. We are going to explain what that means. The 1000 can go up to 12 kilowatt adding channel. That's a lot of output power, and it's chirp ready. So the main difference that you see is the number of channels and the fact that this one is doing split beam and the other one is doing dual beam. We are going to explain what this means. Okay. So when we go to the transducer beam option, which is when we are talking about dual beam or split beam or single beam, we're talking about the sound lobe, the transducer. So if we have a single beam transducer, it's going to be a regular sounder. You're going to be able to locate a target and to provide the exact depth of the target. You all know, I'm sure, the working principle of the echosounder, so I'm not going to explain it, but the single beam transducer is able to locate targets, but it's not able to give any information about the position of the target, nor the distance from the axis, and nor the position, and also, of course, not the position on the sound lobe. The dual beam is an advance from the single beam, because now with dual beam you are able to calculate the angle of one target from the axis. So that gives you the information of the distance of one target from the axis. You don't know the exact position of the target in the lobe. You cannot specifically say where in the lobe is, but you can say how far from the center is. So it's like a ring. So one target is going to be a ring moving out of the center. This is why we represent it like a ring. Split beam is the best of the three, because in split beam mode, you not only know how far is the target from the center, but you can precisely locate the target in the sound lobe. You will see now what this means. So now this is an explanation of how dual beam works. In dual beam, what we do is like we work with 2 beams. One beam is a narrow beam, and the other one is a wide beam. So what we do basically is that we locate the target using both beams, then we choose to only use to measure the targets that are be seen with the two transducers. That means the targets that are in the narrow beam, mainly. And then when we measure the target, we don't use the narrow beam, but we use the wide beam because it has less error. You see this line here is going to be like the ideal, and the narrow beam is going to have more difference from the ideal than the wide beam. So you use the wide beam to measure. Since you know the distance from the axis, you can apply compensation to the target. But you don't use the narrow, but you use the wide beam to measure. This allows you to stay near the center of the lobe, which is the ideal position to measure. And since we are measuring with the wide lobe, the error is less and the compensation you have to apply is less. It's not the ideal thing because if I have a dual beam transducer, it can happen that with the use a transducer, let's say this is a round transducer, and it's transducers are not bricks. Inside, if you open a transducer, you will see different elements, different ceramic elements with a particular layout. I don't know, the one you want. If you're using dual beam, you cannot tell where in the sound lobe is going to be the target. So when I use in the transducer, it may happen that one part of the transducer stop working for any reason. I don't know, water or mechanical failure, whatever. So this sound lobe is going to be like this, if you can draw it. So meaning that this part of the sound lobe will have this error. So you don't know if your target is here or here. So you don't know exactly if this target is going to be precisely measured. If it's insonified with this part of the transducer, low performing. So dual beam can have that problem, and you cannot identify, because you cannot make a compensation in dual beam the way you can do it in split beam. So that's the disadvantage that you have with dual beam. The advantage that you have with dual beam is that you can use in dual beam you can use regular dual frequency transducers. What you need in dual beam is one wide beam and one narrow beam. The wider is the wide beam, the better. The narrower is the narrow beam, the better. The thing is, the wider is the wide beam, the less range the transducer can cover. So there's always a trade-off there. It's like you have to. We provide the dual beam with system with normally standard with the CM599 LH or CM265 LH from Airmark. Okay. This CM letters is the enclosure of the transducer. It can be, I think they have different letters. If this bronze enclosure or rubber enclosure, that this is not important. The thing is, we use these two models. Same one that we're going to use it for the 1900. And the thing with these two models is you have also many frequencies available. So I'm going to explain that. So you have So you have different frequencies available, and you can do chirp with these transducers. And this gives the vessel a lot of flexibility when changing seasons. So they fish in one season pelagic and the other season bottom. They use different frequencies. When you install a vessel, a regular split beam sounder, then split beam will be like one frequency or one small range of frequencies. So the vessel have to then install 2 split beam sounders, and that arrangement is very expensive. So dual beam can solve that. But you will see during the training that is dual beam cannot be the same as split beam. Okay? I'm not going to say split beam is going to be more accurate. I'm not going to say that, and I will explain that. But it can be the case. Some of you remind me that there is one LHW from Firmware. The thing with LHW is that the W stands for wide beam. Okay? But this wide beam is in case of this transducer is the you know that normally in acoustics the lower the frequency the wider the beam. Okay, so if we go low frequencies like 38 or 28, the beam you expect that the beam is wider. The higher the frequency, the narrower the beam. So in this case, in the LHW, Firmware produces a transducer in which the wide lobe is the high frequency lobe. So they have a 25 degrees wide lobe in the high frequency. So this is not so good combination, because you know that high frequency, because of the absorption and the spreading, high frequencies, you lose high frequencies earlier. They don't go deep. So the result is, we will see when we go through the comparison of the different models of transducers that we have available, but you will see that the difference on the maximum depth that the LHW can handle. So it's possible to do dual beam with this one, because it has that one narrow and one wide beam. But the thing is, the wide beam is a high frequency. So remember that we are measuring with the wide beam. We are measuring with the wide beam. If we lose the wide beam shallower, then it might be the case that we cannot measure properly. If you go over 100 meters, I don't recommend to use LHW for more than 100 meters. Measure it. Okay? In case of LH, the case is totally different, because it's regular. The wide beam is a low frequency, and the okay. Okay. Split beam works with a different concept. Split beam don't rely on the target strength to locate the target in the lobe. In case of a split beam, what split beam does is it measures the phase deviation of the target, and it uses the force sector of the transducer to measure that phase deviation, and through that measurement, it is able to precisely locate the target. I'm not going to go through the mathematics of the split beam, because they are so boring, and it's not the point here. But if you want to go through the mathematics, here is, I have this blue book, which is my Bible. I'm happy to share it with you. Look, this means that I've been working on them. Okay. Dual beam and split beam. dual beam uses the target response in sound in two different transducers to calculate the target position in the sound log. The precision of this calculation might be affected by the target species response in sound. This is very important. You know that all the species of fish doesn't have the same sound, the same response in sound in all the frequency band. So if you're using dual beam, it might be the case that one particular species had no good response in low frequency, and that is normally we use the LH. The low frequency is the one that we are going to use for measurement. So if the species has not good response, it might be the case that we cannot precisely locate that species and precisely make the dual beam. This is the bias that the dual beam can have. If you don't have like a plain response in sound, then it might be the case that you have to compensate that difference, and then you're starting to lose some accuracy there. Split beam, on the other hand, provide the exact location, regardless, the response in sound of the target. So here you don't rely, you don't mind the response in sound. So you measure difference in phases. So here the behavior of the fish in sound is not important. So that being said, if you're working, for example, with some pelagic species, they have a particular behavior that, for example, I'm gonna make this is frequency here in the x-axis, and this is TS, target strength. So this is going to be an acoustic signature, the response in sound of one fish. Okay, so the green line is going to be the code. The code is something like this. So the acoustic signature of the code is, so let's say this is 28 kilohertz and this is 200. Okay, so the code response in sound is better, is higher when we use lower frequencies, but it's going to diminish as we move in the frequency to higher frequencies. But anchovies, for example, is like this. So you have a portion of the low frequency that you don't have a good response to, but then you have a lot of bandwidth that the response in sound of the anchovy is very plain. So for some pelagic fish like anchovy or sardine, the dual beam can work with good accuracy. But if you're measuring like whitefish, bottomfish, like I don't know, haddock or cod, the behavior in sound is not so good for dual beam. So if you have an application that if you are looking for cod at high depth and you want to measure it, not only detect it. If you want to detect it, you put the dual beam sounder, it's okay. You're going to see the code. But the thing is, when you want to measure it, it's different. Then if you want to measure the code, I will recommend to use a split beam in 38 kilohertz. But if you want to measure anchovy or sardine, I will recommend to use a dual beam, because you're going to spend less money and you're going to probably have the same output. Okay? Okay. This explains what I just explained. Okay. Example, the anchovy and the cod. That's what I explained here in the graph. Okay. And this is what I just said. Suggested implementation of the FMF-1000 and 900 with medium or large bottom trollers working for cod or haddock, tuna, poor seiners, or bottom trollers are very high depth. We recommend to use the 1000. For mid or small poor seiners working at midwater pelagic species like anchovy, mackerel, or sardine, mid or small trawlers, twin rig shrimp boats, we think that this is not like a fixed rule, you know, it's sometimes it's going to happen that perhaps it's backwards, but generally speaking, that's what we recommend. Okay. One important thing is the depth here. Bottom trawlers in the case of 1000, the bottom trawlers working at high depths is because of the channel adding features, which is you can do channel adding in both equipment, but in case of 1000, you can add up to 4 channels, so it's going to be more output power. It's a simple concept. Chirp or CW? The big question when it comes to selecting the right echosounder to one client is when to use CW, that is the normal pulse that the echosounders been used for years, or the chirp mode or FM slide pulse. It's new for echosounders, not new for radars, but it's new for echosounders. It started appearing in echosounders like 10 years ago, maybe more. Yeah. In professional echosounders, yes, and maybe in recreational echosounder started to appear earlier, but in professional echosounders, we've seen it. The first Simrad system in chirp mode appeared with this ES80, and that was in 2015 with the launch of the ES80. And the same year, Furuno presented the FCB-1900, which also was the chirp available. Why to use chirp and when I don't recommend to use chirp? There's a lot of good things that come with chirp. And perhaps there's only a tiny reason not to use it. But the thing is, with chirp, you have wider bandwidth, you have better signal to noise ratio, that is, noise does not correlate. So you're going to filter noise by doing chirp. It's not that you have to apply filters, you can do it, but the system itself is a filter for noise. The main advantage of chirp is that it deploys a tremendous improved acoustic resolution. It's not the word best is not good describing the advantage in vertical resolution. That, for example, in real fishing condition, we've seen like 7 centimeters vertical resolution, 10 centimeters, it depends. in laboratory conditions, we've seen 1.5 centimeters of vertical resolution. Is very impressive what you can do with chirp pulse. There's a limit for resolution. We will explain it. It has to be, it is related with the one unwanted feature that we have in chirp, which is the side lobes. And we will explain it now. Because you have an improved vertical resolution, which is independent from the pulse length, you can do in chirp, you can do very long pulses and still having that resolution. In CW, when you do a long pulse, you lose vertical resolution, you know. So in CW, to be able to have a good signal-to-noise relationship, SNR, so you have to have power to overcome the noise. In chirp, that's not the case because the correlation lowers the noise and you are still able to retrieve signal even within the noise. So it's very powerful to, especially in very noisy environments. Chirp allows you to, when you're using the echosounder to measure size, TS, it allows you to identify and measure more individuals because of the improved vertical resolution. So in one water column, you can, in CW, let's say you have a pulse of 1 millisecond, then you will have 75 centimeters vertical resolution. In chirp, you will have 7 centimeters, perhaps. So remember that if we're working in CW and we have a fish aggregation, the equipment will not measure. Perhaps it will discharge, it will not clear all the filters of the split beam because it will read we will explain it tomorrow when we explain all the limits of the TS measurement, but the system will see no good echo for measurement, so it will. But with chirp, it will identify a single target here, a single target here, a single target here, so you will have 3 targets measured. So result is better measurement. You have more individuals measured. Produce better statistics because you have more individuals. For bottom fishing, so the unwanted feature of the chirp is the side lobes, which is a product of the correlation. So in chirp mode, because of the correlation, you generate noise. So that noise is not there. It's not because of something that is produced from an external source. It's something that is mathematically produced because of the way that you correlate the signals. And that we call side lobes from the correlation. There are side lobes from the transducers, unwanted signals that the transducer transmit, but also there are side lobes because of the correlation. These side lobes, we cannot do anything about it. We can do something about it, but we can not avoid the system. If the system is using chirp, we cannot avoid side lobes. It's like when you're running your car, it's going to produce CO2. If you're using gasoline, it's an unwanted subproduct of the correlation. Okay. Side lobes, when you're using chirp and you're using mid-water chirp, is not always a problem because the side lobe from one particular target may not be so important and you will not appreciate it on screen. But the bottom, on the other hand, is a very important target. It's the most important target of all. So the side lobe from the bottom is going to be a problem. You're going to see, like, this is the bottom. This is the bottom here. And you're going to see like a cloud on the bottom. Sometimes this cloud could rise up to 2 meters or 1 meter from the bottom. And if you are using this system for bottom trolling, then the system in chirp mode might not be good. We can apply a filter we call tapering. We apply tapering, and then we do like this. Ooh, no more side lobes. Magical solution. Okay? That's what Furuno uses. Tapering to remove side lobes. But when you use the tapering to remove side lobes, you also remove targets. Okay? So, but when the targets are, the thing is, you remove targets, the engineer here is not gonna let me lie, but I understand, I remember that, correct me if I'm wrong, I remember that side lobes can be like 40 dB?
Less.
Less?
Yes.
50 dB? Okay. So if your target is like a shoal of fish, might be minus 30 dB. So it might be the case that this bigger echo, you will see it because it will go through the filter and it will manage to survive the tapering. But if you're looking for spreaded fish, no big aggregation, no big shoal, then the response in sound will be lower, and they will end up killed by this tapering filter. Okay, so it's a short blanket. You use chirp, you will have to apply tapering if you're using it bottom fishing. Then you have to consider that maybe for that particular client might not be ideal. But it will depend the place that the vessel works, the particular behavior of the fish. If it is fish that comes in big aggregations, then you can use chirp because the fish will survive the tapering, so you will see it. But if not, then it might be the case that it's necessary to switch to CW for bottom fishing. So that's not a rule. Bottom fishing, CW. No, depends. Depends if we apply tapering and we continue to see the fish in the bottom, then it's better to stay in chirp because of all the other advantages. You will have a lot of advantages. So stay in chirp whenever it's possible. But if you're working in the bottom area, then be careful with this, okay? On the other hand, CW has a lot of bad things. Restricted bandwidth. Restricted bandwidth was used in CW because in CW, remember that we have to compete, we fight with strength the noise. So what we do is we restrict the bandwidth because we want to mess with only one noise at a time. So we don't want a lot of noise. So we restrict the bandwidth to eliminate noise, and we stay in this band because we are using one frequency. So we are using one frequency. We don't need 10 kilohertz of bandwidth. We are only using, so all narrow band transducers were 38 kilohertz. They were from 37 to 38 and to 39. There's not so much bandwidth there. So if you have a narrow beam transducer, forget about chirp. You cannot use chirp. Signal to noise ratio depends on the level of the signal and noise. Very noisy environment will demand very high power systems to overcome the noise, because otherwise your system is not going to work. Acoustic resolution is related with the pulse length. Remember, if I use a longer pulse, I will have a worse vertical resolution. This is going to increase as I increase the pulse length. The vertical resolutions will be worse. So you will not discriminate fish. At one point, you will see one chunk that doesn't mean anything. Allows, because of that poor vertical resolution, allows a smaller number of individuals when compared, measured when compared with chirp. The bright side, on the other hand, for old school guys, is there is no side lobe effect on the bottom, because we are not correlating anything. So we don't have side lobes. But believe me that we tested recently in a fjord in Norway, where there was a lot of life, a lot of algae, and a lot of sources of noise there. And when you switch it back to CW, you could see the difference. It was when you use it CW or chirp, it was like when you're using chirp, you're actually using the echosounder. You can see. And when you switch to CW, it's like you lose the echosounder. It's like you don't see anymore. You have to low down the gain so much to avoid the noise that you lose many of the signal. So it's in CW, like if you're fishing in clean environments, and when I say clean environments, I mean clean from noise sources. Okay, it might be the case that it will work fine. We have a lot of examples in north of Russia, recently installed in Russian fleet working from Murmansk. And the Barents Sea at the north is a clean environment from noise sources, and so CW works fine there. But some Norwegian fjords are very complicated for CW, and might be the case that you will have to mandatory use chirp there. And when you're using pelagic fishing, there's no question. It's a must to use chirp from my perspective. So for client advisory, you have it more clear now. It's I will try to use chirp whenever I can. I will say that 90% of the time I will recommend to use the chirp. I will say only 10% of the time I will say be careful with chirp, because if you're fishing bottom fishing, be careful. Okay, here we reach a point in which we open the session for questions, Q&A, questions and answers. So if you have some question, I'm all yours. If not, bottom fishing.
Strong fishes, quote.
Yes.
Yeah, I can use the chip.
Yes.
If say shrimp or smaller.
Definitely, bottom fishing for shrimp is a very complicated for acoustics, because all crustacea, it's has a very low response in sound because of its characteristics, physical characteristics. We will see it tomorrow because we will go through detail how an echosounder measure and detects. But when with the shrimp, you have a shellfish and there's no swimming bladder inside. So there's no, that target for acoustics is a very bad target. And shrimp depends. If you have big aggregation of shrimp, then the scattering will be big. In Argentina, for example, you see echosounders, 100 meters shrimp, big chunks of shrimp, and you see it. And you see it, and the fishermen in Argentina, for example, uses the difference in frequency to detect. They use 50 and 200, and when they see the shoal in 200, and they don't see it, or even merely see it in 50, they know for sure it's shrimp because of the shrimp response in sound. It responds poorly in lower frequencies and very good in this. The shrimp is like a acoustic signature of shrimp is like this. So in lower frequencies, no response. In higher frequencies, very good response. So they use 50 to 100 echosounder, and then they see 50 not so good trace, or even they don't see anything. In 200, they see a big chunk. But normally, outside Argentina, shrimp is not like big shoals of shrimp. So it's good. Your question is, it depends on the species that you are targeting, of course. Not only the aggregation, but the species is very important also. We have any questions from the streaming?
Not yet.
Can you? No question?
No question.
Okay. Now we are going to start looking at some technical aspects of the installation. After this block, we will do a coffee break because we will start. Yeah. Okay. Don't worry. I will try to make it short. Okay. I will say is the source of 80% of the problems, technical problems that you could have with the equipment. And I'm saying 80, but I believe that is more than 80%. So the moment you install the equipment, you have to be particularly careful. It's a very important moment, because this is going to be the moment in which you will be avoiding future interventions, future stress with the client, and future problems. I know, because I've been there so many times, that when you arrive Bissell, sometimes it could happen that it's not a new building, or even in new buildings, happen that you will not find in the shipyard or the contractors the best reception when you ask for installations, particulars for the echosounder. Sometimes you will go on board and you will see, I don't know, existing pipes with existing cables, and people on board is not so, I don't know, disposed to allow you to make the ideal installation. You have to be very firm and very clear with this. If you don't manage to be close to the ideal with the installation, then when the skipper comes on board and trying to use the echosounder, the result is it's not going to be the idea. But the thing is that when you're installing, the skipper is not there most of the time. So you have to be like the skipper advocate, okay? So you have to fight for the skipper, because he's going to use the system, and the people on the yard is going to push to finish the job quickly. Don't mess with special conditions, and it's going to push you. Don't let them push you, because this moment is very important, and if you don't take special care in this moment, then you're going to regret this in the future, because you're not going to deliver the performance that you want to deliver to the client. In this module, we will see ideal installation parameters. We will go through the transducer selection and location, and mounting, the location of the black box unit, CPU, cabling and connectors, junction box, synchronization. Synchronization is, I never believed that I will encounter such resistance in some skippers, especially here in Spain, for synchronization. They don't want to synchronize equipment. I don't know why. Because they use, here in Spain, they use like 3-4 echosounders, 3-4 sonars. So it's a feast of acoustic sound in one chip. And then if you don't synchronize, then you will have all that feast of interference in your sounder. So it's, I don't know why, but they don't want to synchronize, and that's something weird. The ideal installation: transducer in the deepest part of the chip, closest to the center as possible. The literature says in the end of the first third from the bow, that's the ideal location of the transducer. The ideal location of the transducer is the ideal location of the transducer. Then you go to the boat and see, you have to consider that the transducer must be far from sources of noise and interference. And sources of noise and interference are all the engines, all propellers, but not only that, but the navigational effect of the hull creates bubble. And the thing is, we will see it, but the thing is, the first third has is a Y for the first third. Transducer cable entirely inside a dedicated beta pipe, electrically isolated. Dedicated. Can I put the transducer cable with, no. Can I put 3 transducer cable? No. Why? No. Why? I'm going to tell you why. Interference is why. Maintenance is why. I have to remove that transducer. Let's say I have to remove that transducer 3 or 4 years after I install it. If you install it with like a bunch of cables, oh, good luck. Good luck. Okay? So, yeah. So dedicated, isolated, please. Okay? I remember one installation, Simrad and Seaman. Okay. So Seaman technician came on board. He asked, isolated, dedicated pipe. Okay. Isolated, dedicated pipe. Simrad guys came. Okay. Can we put the transducer line using your pipe? No. No. Will you allow your sounder share pipe with my sounder? If the case would, no. Okay, so build your own pipe. It's not because you are my competitor. It's because you will, it will be better for you and for me. So this is a problem in the shipyards, because they don't want to, oh, there's not enough pipes. Oh, we have to add another pipe. Wow, we have to dismount all this. Do it. Because that is the moment, not when then the skipper will be in your head all the time. Okay? Black box unit installed at the transducer cable end. At the transducer cable end. Can I splice the cable? And yes, you can. I don't recommend. No manufacturer will recommend you to increase the length of the factory length cable of the transducer. Why? Because that cable is an antenna. So that if you have a longer antenna, you have a better reception of noises, you know? And that always use a reliable and stabilized power supply. Very important. Very important. To avoid system blackouts, to avoid system failures because of, okay, always. I cannot be strong enough to say always use a reliable power source. If you don't trust the power source, then go to the ship owner and tell that, call the electrician guys and put the right conditions to the power supply. We always recommend to use UPS because we are dealing with the sounder and the CPU are 24 to 30 volts, but the screen is not. The system using a UPS will be stabilized, will be isolated from blackouts, from the. Sometimes we use the system with 220 and they switch engines for the switch generator, so that it says, we have to avoid, remember that the sounder is based on a PC. So every time we like took the power out without the proper protocol to turn off, it's a problem for the operating system. So transducer selection, pictures are for the most popular guys in town here. We also provide split beam transducers in 38 kilohertz, in 120, in 70 kilohertz. So, but the picture is for the most popular one that it. When selecting transducers, you have to consider these specifications as follows: working frequency and bandwidth, transmitting power, and figure of merit. Figure of merit. We'll see it. Parameter for choosing the right frequency. For choosing the right frequency, there's no news for you. Target species is one of the parameters you have to keep in mind and work in depth. This is very simple. Not all the species, as I told you before, reflects the sound the same. Some species will like, if you allow me the word, higher frequencies, and other species will prefer low frequencies. Code is the case for low or mid frequencies. For code, I will use a range from 38 to 70 kilohertz. For pelagic species like anchovy or sardine or mackerel, I will use a higher frequency like 120 to 200 or higher. It also depends on the working depths, because sometimes it can happen that you want to use a higher frequency, but there is a trade-off because you're working at high depths. So you start going to the middle because there's no high frequencies allowed at that depth. Sometimes some vessels, they fish pelagic, but at very high depths, like 300, for example, in the Pacific Northwestern in the US, they fish mid-water at 350 meters. So that's a tricky one. You say mid-water and you think pelagic, like 90 meters or 100 meters. This is 350. So not all pelagic fisheries allows you to use high frequency. So you have to keep that in mind. Selection chart for the most popular transducers from Ermer. Here we see, remember we've been talking about the LHW, the one in the center. Look at the high frequency difference from the other. So the difference is the same transducer than it's the same as LH, but what changes is the element in high frequency is smaller, because it's with smaller elements you create a wider beam. But doing that, you lose a lot of range. You lose a lot of range. Yes, you improve detection because you have now a wider beam, so you detect more echoes with one ping, but you will lose range with that LHW. For example, here in Spain, for some fleet that is working in Malvinas area, in the south of Atlantic Ocean, we use the CM-599 LM. They fish for squid. And the medium frequency is good for squid. The LH is the most popular one. Is the one we use the most, both in 265 or 599. For low depths, I will say, if you look at this chart and you only look at the range, so you will say, okay, most of the time, I will choose the 265 because it's, you know, if you only consider the maximum range, this is the maximum range informed by Airmark. If you only consider that, you will say, okay, for me, most of the time, the 265 is okay. But now, there's another parameter that I want you to look at. This is the figure of merit. Figure of merit is what transducer can deliver out of the voltage that you put on the transducer. You transmit and you receive. And there's a relationship between transmitting and receiving. And that creates that curve there is the figure of merit. So if you're using 265, the figure of merit is compared with the 599. There's a lot of difference. 10 dB, it's a lot of difference. So it's not just that you look at the maximum depth that the transducer can reach. So it's at the same depth, working at the same depth, the 599 will be a lot better. It's not only, you will be allowed to operate 10 dB higher. So think about the gain adjustment and think about 10 dBs of gain is a lot. So you don't have to only consider the maximum range, but you have to consider the figure of merit when selecting transducer because it's very important. If you're detecting small fish and you have to correctly filter the noise and you're detecting small fish, perhaps, it doesn't matter if you're working in low depth, perhaps you will need to choose the 599 because of the figure of merit, not only the maximum rate. You're not going to fish 3,000 meters, but you will need the better performance of the 599 instead. This not only applies to the 599 or the 265, it applies to all the transducers. Most of the manufacturers inform, if they are serious manufacturers, they inform the figure of merit of the transducer. So it's a good practice for you, technicians or even commercial people that is suggesting equipment to the client. First, take a look of this information before suggesting any particular transducer because it's gonna be important. Transducer ideal location, we said before that is at the end of the first third of the hull from the bow, where the water flow still laminar. I will show you an image about that. As far from the propeller as possible to avoid cavitation noise. Not near the bow to avoid physical damage. In some vessels, they put the transducers in the bowl of the bow. That is good for the noise, but the transducer is physically receiving damage all the time. It's not a good place for the transducer. The deepest part possible of the hull from the surface to avoid turbulence and bubble. And always you have to consider the tilt of the vessel. Sometimes the vessel, when it's fully loaded, changes the aspect of the inclination. So when you're designing the binder of the transducer, you have to keep that in mind. In this funny picture of our vessel here, you see that the first third of the ship, the water flow is still laminar. There's not so many bubbles there, but as you go to the back of the ship, you will see that bubble is start producing. Bubble is our enemy. When bubble gets into contact with the transducer, we lose all the signal because air and transducers are not good friends. Yeah, when you put air between the water and the transducer, you will have cuts, vertical cuts. You will not receive anything. You will not transmit anything because the sound transmits in water a very high speed, 1,500 meters per second, but in air it transfers 340 meters per second. So there's a lot of difference in speed. So the different density of the media, it doesn't allow the sound to propagate in the air. So you will see that we will see in the troubleshooting after the break, you will see that the cuttings on the screen. If you have a bow thruster, then it's not good, but it's better to put it before the thruster. The thruster, this is, I don't fully agree with this because the thruster, you don't use the thruster in fishing maneuvering. You use the thruster only. This is a generic recommendation. Yeah. Yeah. Still bubbles, yeah. The transducer binder, 1 meter from the keel. 1 meter from the keel depends on the size of the hull. It's a generic, also generic of what means you put it a little bit outside the keel. The inclination is also important. Inside the keel is one of the, it's not a bad place inside the keel. I will see it. This is the traditional binder mounting. This is an image from Airmark. Those are images from the Airmark website. This is the keel mounted. It's not, if you're not like touching the keel with the ground, if you don't expect that, you laugh, but in Argentina there are some fishing ports that in some part of the day, the boats they stay on the ground. So this is not good mounting for them. And you can do an inside hull mounting, which I don't recommend for fishing for professional. This is for recreational fishing in fiberglass boats. You cannot do this in metal ships. It's not. I don't know if you can see it because it's so much bright, but this is an example of one binder that we designed in Argentina. We use in Argentina. We use this. I use this photo because we also install these flanges to the flanges here are for this. We want to not allow the turbulence. Here is the binder. So the water flow do like this. It cannot do like this. It cannot go down. If you don't put the flange, sometimes this happens. Okay? So some boats, they don't want to put the flange because they are afraid that the net can get stick to the flange. When that happens, we recommend to try to put the flanges because it will be better for the noise. Instead of putting only the flanges, they put rods up, and so the net cannot get stick to the flange. Yeah. Ice also. Yeah. Very important. Cable installation. Individual steel conduit. From the black box to the gland. because you lose, if you don't do it like that, you lose isolation. Never with electrical cables, never. It can be shared with some signal cables of other sources. I don't recommend. I always recommend individual pipes for other reasons, not only for noise. It's extremely advisable not to extend the transducer cable line. We've been in the situation that we had to go back in an installation and put the black box down because the extension of the cable created a loss in the performance, very important loss in the performance, especially when this vessel was fishing in Africa, very high depths in front of the coast of Africa. And that was a problem for detection, and we had to move the black box down. Avoid from hot or very hot or cold places because of sometimes ice can damage the cable when you put it in near ice. Not to not to reuse existing cable. Oh, there's a cable here. Can I? No, yeah, cut the transducer here. Yeah, okay. Yeah, okay. This is the recipe for disaster. Okay? So if you want to have a big trouble, then you can use yeah. You can do it. I mean, it's up to you. Avoid splicing. When it's possible, avoid splicing the cable of the transducer, especially when that splicing will be underwater. Avoid splicing. I know that being you such experienced guys, I know you've been in the situation that you have to splice a cable. And you're looking at me and you're saying, okay, this guy is going to tell me how to splice a cable. No, I'm going to tell you not to splice a cable if possible. Okay? Because any splice, the better you do it, you are the best guy in the world to do splicing, is a risk you're taking. So if you avoid it, better. We recommend instead of splicing, it's better to use isolated junction box. That will provide a safer splicing. So it's black box installation as close as the transducer as possible. We recommend to use a power supply 24 volts. In case of 910 amps, 20 amps in case of the 1000. Transducer cable section, in case you have to extend the cable, that is the 4 millimeters for 10 meter cable length, the section of the cable. For black box installation, we recommend to put the black box in a dry and ventilated area. Remember, we will go through the temperature, but temperature is also a thing we have to keep in mind. Properly grounded. I've seen echosounders with no grounding. No, I removed the grounding because I have noise. Why you have noise in the grounding? Check the grounding. Use proper grounding. Never use grounding. Use grounding, the grounding has to be good. Sometimes you have boats that it's very difficult to have a good grounding because they are wooden boats or metal or fiberglass boats. Then I wish you good luck. You have to have a proper grounding point installed on board always. We done a trial in Norway. The trial we done in Norway, we did it in a fiberglass boat. It was a feast of sound and noise and no good grounding. We had no good grounding, no solution for that. Away from no noise of sources, of course. You don't want to create problems yourself. Okay? CPU installation, mostly the same, but you have to ask, it had to be close to the screen, and because of the maximum length of the video cable, stabilized 24 volts power supplies. Screen resolution mandatory in our case has to be at least full HD. The system will not operate if you don't have a full HD screen. It should be also in a dry and ventilated, or also with the proper grounding. What you see here is, I'm going to go fast with this because it's like a lot of technical things, but junction box. When we provide a black box, we provide a junction box. Sometimes we don't provide it if you don't want, but we strongly recommend to provide a junction box with the equipment because it's going to simplify all the connections. In the junction box, you connect all the transducers, you connect the power source, and you connect the synchronization. So those are the three things that you connect. And you connect also the temperature
yes.
Temperature sensor if you have an external temperature sensor. All this section here is for transducer port. We provide 4 points of connection of transducer because this junction box is either for the 1000 or 900. Temperature sensor, trigger input. It has two trigger connection. One is receiving trigger from external source, and you can also, if the external source is not compatible, you can create a compatibility for, let's say some Furuno models have no external trigger, so we can plug there. We will explain it in detail. The external trigger input, normal, regular one. The output. When I'm the master, I'm putting the output. So for synchronization, I will take 2 minutes for that. Synchronization, we have 2 ways to synchronize. One way is the normal synchronization, in which you say both equipment will transmit at the same time. So that's regular synchronization. So you say that the equipment, okay, let's transmit, and they both transmit at the same time. But we have another way to synchronize, which is alternative. It's like a multiplexer. So you can connect another equipment, and you can say, okay, I will give you the turn for you to transmit. And this is good to use, especially when you're using, when you're operating 2 chirp devices, because chirp is for synchronization, it's very tricky. So we recommend to use this when you're using chirp. And the power supply input is there, also with the proper fuses. And this is a picture of a very important fishing vessel that we installed in Argentina, and this is installation success case. It's an installation. We apply all the ideal, and it works. It's when you can do it, it works, and you don't have problems. And that's the message here. Okay. Now is time for your questions, and then we will open questions for the audience streaming, and after that we will have a short break for having a coffee. And okay, so I'm yours. Do you have any question? No. Is there any question online?
No, just in a moment when you were explaining the junction box.
Yes.
They asked for what is that?
What is the junction box?
Yes, because they lose.
Okay. I have to go way back. I have to go way back to the layout. And remember when we explained the layout, the parts of the system, we said that the system is provided with a junction box. A junction box is a device that gets in the middle in between the trigger connection, the power connection, and the transducer. So that is for simplifying the transducer to avoid splicing and connections roughly done. So what we do is we provide that junction box, which is an accessory of the echosounder. You can order the echosounder without the junction box. We don't recommend to do that because it's gonna be a cleaner installation, and we include the junction box in the price of the echosounder, so it's no point. It's not going to make any difference in the price. So it's a part of the system. So it's going to be for you to say no, but no point on doing that. Okay. If you don't have any other question, we will. What?
You say that you should have proper balance power supply. When you're using, if you're connecting to batteries, you always have difference in charging and load and voltage.
Yeah.
Would be maybe.
The system is ready to absorb some variations in the voltage. But I recommend not to play with that because it's a risky game. Yeah, I recommend that. I recommend that you put in the middle something to stabilize the voltage because you're putting a very delicate and expensive piece of equipment here. Yeah. And then if you're plugging into a battery, and you know batteries are greasy things, dirty, and then they tend to not absorb the charge not all the time. The battery lifetime. Some vessels are they have very in detail the electrical maintenance. Some others not. So you have to be independent from that story. Yeah, it's a small cost when you compare it with the cost of the installation or the. And you can even share the power supply. You can, if the power supply is good for more than one device. I don't recommend to share it, but if you have to, because it's another source of noise.
I mean, if I'm doing the installation, the main issue would be to do the installation and have no problems.
Yeah, that's what we explain. The ideal installation is in order for you to avoid a headache after the installation, because it's if you follow the recipe, it's like the recipe for calamari. It doesn't fail. You follow this recipe, then you will not have any trouble. Of course, you can have a warranty issue. We sell equipment, and equipment can fail sometimes. But if you do a proper installation, you will avoid a lot of trouble.
But software, you can always use like Firmware or something. If you have a hardware issue, then
hardware issue, you will need the chip at the port, and if you have a hardware issue while the vessel is working, and then you have a big problem, and you have a skipper complaining until it arrives to port, so it will be a big time trouble. So I cannot stress more. Be very careful when you, and I put I know I'm boring you with this. I know you know it, but I have to say again, please be careful with the installation because it's the source of many problems. And when you encounter some clever guy from a shipyard, try to explain this. You're selling acoustic precision device. So when you're selling acoustic precision device, you have to be precise and very careful because this is very sensitive equipment prepared to listen. You have to understand that this equipment is prepared to listen the response in sound of one fish at 800 meters. So think about what can do the noise on board. So you have to be very careful with that. It's not you're installing every equipment of a fishing boat is important. Safety equipment is very important. Navigational equipment is very important, of course. But this is what brings fish on board. So this is, the skipper is going to give you a headache if this doesn't work. So be very careful with this. You can reposition an antenna, radar antenna, with the boat on the water. You cannot reposition a transducer. You have to go to dry docks. It's a very complicated maneuver. So when selecting the position to the transducer, be very careful. Be very careful. I cannot stress it anymore.
Just one thing also about when you talk about the transducers, the difference. You have the same with radar, and everyone understands the difference in radar. You have like a radar with a long range, which you cannot actually see, but it's just a small angle.
Yeah, that is true. That is true. And that is why you, technical advisors from the client, you have to carefully read the specification of the transducer, be careful with the figure of merit, be careful with the angle of the transducer, understand what means that having a narrow or wide beam, and understand what means that having a low and high frequency, what frequency to recommend to the client is very important. This will avoid problems then when using. And the end is a happy customer when you select it, when you recommend the right equipment and the right transducer, and you perform the ideal installation. That's a happy customer. And that's what we all want. Let's have a coffee. Coffee break. Okay. Okay. Welcome back again for all the people joining us through the streaming. And so now we are resuming our training for today with this block in which we are going to discuss what we call troubleshooting. But you will see when we go through the things that we see are the most common problems that you will encounter on board, that mostly all of these trouble are produced because there is not an installation properly done, not ideal installation. So the first issue that we will go through is temperature. So the ideal operation environment temperature goes from -5 to positive 55 Celsius degrees. And the the black box internal operation temperature rises between 15 to 20 degrees from the environment temperature. So this, keep it in mind, because the black box is able to work more than 55 degrees, but you have to keep in mind that it increases temperature inside. So the black box has internal sensors to sense the internal temperature. It's always self-controlling temperature, and you will see now what happens when the temperature goes out of the specifications. So when operational temperature rises, if the temperature inside the black box, remember that we told you before that increase of temperature. So when the temperature inside the black box gets up to 70 degrees, up to 70 degrees, the performance is 100%. You're not going to see anything, any warning, anything, and the system will operate okay. So my recommendation will be keep the internal temperature under that value. From 70 to 80 degrees, the system will give you a warning, and it will start diminishing proportionally the performance. So as the temperature increase, so the system will start to decrease the power output to try not to generate heat inside. So when the temperature reaches 80 degrees, and here you see a warning. So the system will warn you. There's a tiny red triangle. You will see an alert there, and you will click the triangle, and it will say, okay, you have a temperature problem. Do something, or either if the temperature increases over 80 degrees, the system will disable. It will stop transmitting the software. The CPU will keep on. You will not have any transmission from the black box until the temperature goes down and you reach an operational temperature. This is for an alert will appear also on the screen, and then this is for system self-protection. To avoid this, we suggest that you keep the black box and the CPU in an environment that the environmental temperature is in between that boundaries. It seems that it could be, when you see 55, it will sound like a high temperature, but some vessels to reach 55 degrees, it's not so complicated. You install the black box depending on where you install it. Sometimes small vessels are more problematic than big vessels, but because you have all the equipment together, and so the equipment is with other sources of heat, generating heat, and needing to ventilate itself, and in that environment, and you add the external temperature where you guys are from, external temperature is very low. But if you go some places, for example, some fisheries in Africa or some fisheries in Central America, temperatures rises very high, and this could be a problem. Try to avoid installing the equipment in unventilated places or with other sources of heat. Sometimes the heating system of the wheelhouse or the place you install the black box is a problem. Keeps you warm, but it will be a problem for the equipment also. So the using of special rooms for installation of these acoustic devices is advisable, like rooms with ventilation and special environment condition. If you have to install the black box in not ideal location, I would suggest the black box will be positioned low, because the heat tends to go up. So try to put it in the lowest part and the most ventilated part of the location you are installing. Suggested position of the black box is vertical, because it's the way the heat sink works better. Try to avoid to put it in this position. Try to install it vertically, because the heat will ventilate more in this way. Sometimes the rack where the black box is mounted is in the wheelhouse, and we cannot avoid it. My last advice, I'm not good with that, but my last advice will be use external cooler, but that a last resource measure, because air coolers are okay when they work, but they tend not to work. They tend to stop working, and they're not reliable. You're not going to spend big money in air coolers, so you're going to end up buying like a cheaper cooler, and that has to work all the time, 24 hours a day. So this is going to fail, I'm sure. So we work it a lot. I'm going to say this: we work it a lot in engineering to avoid air coolers in the equipment. because of the moisture and the dirty coming into the equipment, and also because the air coolers failed. And so we don't like air coolers. Another failure that you see is problems with the power supply in the CPU. So the CPU that we provide is from Nexcom. The maximum voltage range from the CPU is up to 30 volts. If you're using, yeah, I look at this man. If you're using batteries and battery chargers, sometimes that the voltage increase over 30 volts. Our CPUs are provided with an electronic fuse. The electronic fuse will work in a way that it will protect the CPU. So when the voltage overcomes the 30 volts, it will cut the power for the CPU. The CPU, of course, will turn off. And but you will reset the fuse by disconnecting the power line. The fuse will be resetted, and then the system will be able to turn. Once you checked the power, because the advice is first go through the power, check if you're not having a problem, and reset the fuse. Power supply. This is very graphic. What to avoid, what we prefer. Generally speaking, we do not like easier and cheaper solutions. I know this is an easier and cheaper solution, but to go on board the ship, we prefer that you use marine grade power supplies. I know they are more expensive. I know they are not sometimes as easier to get these guys here, but try to use reliable power source. Remember what we spoke when we discussed earlier? Cheaper solution is expensive problem. Yeah. Electrical noise. Another problem that we will. Back to the power supply. I'm sorry. I'm not going to recommend any brand of. We do not provide power supplies, so I'm not going to recommend any brand. Here you see Newmar, and I don't remember the other brand, but any reliable power supply, it can be GRC, Furuno, whatever. If you have a reliable power supply, marine grade, it will be better than these regular switched power supplies that you can buy in a general store, whatever. Try to use that when it's possible. Electronic noise. I'm sorry, electrical noise. Electrical noise will look like this. It's familiar to you. This you will see like these sinusoids in the screen, like with a distinctive pattern. When you see that, most probably is electrical noise. So a distinctive pattern of oblique sinusoid lines appears suddenly on the screen. It appears suddenly, it can disappear suddenly, depending on the source of electrical noise, something that you turn on suddenly. Very common source of electrical noise, very common source is the LED lights. Our best friends, LED lights. So LED lights are good because they are cheap and they are they're low consumption. Lights, but for acoustic devices, they're not so good. Electrical noise is a very usual noise. Yes. To avoid electrical noise, it's advisable to connect grounding and correctly isolate the transducer line. Here it says category 6. I'm sorry, that's a mistake. We recommend at least category 5, but if you use category 6, it's best. Okay, so shielded. The noise coming into the Ethernet cable will not cause generate noise on the screen, but it will cause a down performance of the system because packages of data will be lost. Yeah. In case of the transducer cable or the electrical line, that is a noise that we will see in the screen. Sources of noise: LED lights, battery chargers, motors, rectifiers. Best way to isolate the source. Electrical noise is difficult, very difficult to avoid. So you have to isolate the source and solve it. Otherwise, it will be like it's not going to be like you can move in frequency or apply filters. There's nothing to do. You cannot do anything magic in the software or in the hardware to avoid it. You have to isolate the source and solve it. To identify the source, there are three critical points. I'm sorry. You have to check the transducer line, the power line, and the grounding line. So to identify, this is a general rule, to identify the electrical noise, remove the grounding. If the noise stays, the grounding is not the source of noise. You do the same with the transducer line. You connect a phantom charge to the sounder to protect it. You make it transmit, and if the noise stays, then the noise is not coming through the transducer line. It's not coming through the grounding line. Then it's coming through the power line. Very common is to have noise coming through the power line. Solution: try to isolate the cables. Try to avoid the cables to go with other cables that can be I have seen very, very bad installation in which the equipment cables are like so long, for example, cables that go one way through the wheelhouse, the other way back. So that's an invitation to have problems. You keep your cables as the best as possible and isolated from other possible sources of noise. This is the image, the picture of electrical noise. When we have grounding problems, grounding available on board to use present a voltage reading. It's very common that you check the grounding and you will see some voltage. Recommendation: always measure the grounding. This is a stupid recommendation, I'm sorry, but not so many people check the grounding before connecting the grounding. So it's a good to use to do it. And here is a recommendation of what to do to measure the grounding. I'm not going to insult you by teaching you how to measure the grounding. I'm sorry, but it's a general recommendation. Grounding problems seem this solder is having grounding issues. Removing the grounding, applying grounding, you see how the noise increases. This is when the technician decides to remove the grounding. And then the problem will be worse because so the best thing to do is to have a good grounding and not removing the grounding. Acoustic interference. We like to differentiate what is called noise from interference. We call interference when the noise is generated by other acoustic device. We call noise when the noise is generated by other sources, like could be like I don't know, the propeller, the shaft line, the hull, the vibration on the hull also cause noise. Bubbles could be some volcanic activity in some parts of the world. You have volcanic activity generating bubbles from creating noise. Yeah. Seismic activity generates sound waves that can interfere the sounder. Marine mammals can sometimes be a problem, sometimes in some frequencies. Solution for interference is synchronization. That is why we separate interference from noise. Interference is a kind of noise that we can solve. The other noise, it depends. It depends on the source. But this source is a source of noise that we can solve by synchronizing. Always synchronize. There's no reason for not synchronizing. And I say this because I always encounter in real life that sometimes technicians don't want to synchronize because they think that when they synchronize, the equipment will lose performance and somehow. If you if you do synchronization in the proper way, that is, you put the master echosounder, the one that is controlling the trigger, and you use the faster echosounder, the fastest spinning echosounder as the master, then you will not see any reduction of performance. If you do backwards, you put the slower sounder to control the trigger, then you will see that the other sounder that was performing better, it will down-perform because it will wait for the trigger, the other sounder to ping. So if you want to have a successful synchronization, you always check that the master sounder is the fastest pinging one. If you are transmitting in CW and you have two devices in the same frequency, it's mandatory to synchronize the two devices. If the devices are in very different frequency, it could be the case that the device is not in the same frequency, but it's in the harmonic of the frequency of the device. It can be interfered, not because of the central frequency, but because of a harmonic, the frequency. So it's always advisable to synchronize. If you do it right, you will not see any difference in performance, but you will see that the noise coming, the interference, coming from the acoustic system will disappear. If you have two chirp devices, we recommend to use alternate synchronization, which is the one that creates turns to transmit. Because chirp is a different kind of transmission. It creates a lot of energy, a lot of sound in water. So what we do in that case is we create turns to transmit to avoid an interference. A picture of a common other acoustic device interfering in our sounder. You see that pattern, distinctive pattern as a ladder going down. Those are, in this case, you see in a light blue color because the gain is very low. But if you increase the gain, you will see that those are chunks of very intense echoes, which is because it's the transmission pulse of the other sounder. Sometimes the noise can come from mechanical or displacement sources. It has a particular, you will see this presentation, maybe, it will create like this pattern, vertical pattern. You will see like an equal separation in between lines because that will tell you that it's a mechanical source of noise. So if you see like a pattern separation of that vertical lines, you will see that something mechanical is going on there, something not natural is going on. Sometimes this is called, by the way, this is one of the most difficult noise to solve because it sometimes comes from the propeller cavitation of the gearbox. Sometimes one gear in the gearbox is failing and it changes the normal frequency. All the equipment on board, mechanical equipment, have a noise in one frequency. You know, when they operate, they have a noise in one frequency. When they change specification on the operate you have a gearbox and you have a bad gear, then the noise of the gearbox will change frequency. And changing frequency, it may be the case that it enters in the frequency of the echosounder. Remember, the echosounder is supposed to hear the echo from a fish 800 or 900 meters. So it will hear the gearbox for sure. So if the noise is in the same range of frequency of our echosounder, then you will have it inside the echosounder for sure. What to do in that case is, well, my recommendation is try to solve the issue of the noise. Sometimes it's not possible because it's cavitation from the propeller. And there's a little thing to do if the ship doesn't go to dry docks. But if such thing can happen to you, what you do here is, if you cannot solve the source, then you try to avoid it. Our equipment provides a tool, which is a noise analyzer. You put the echosounder in reception mode, in hydrophone, and you perform a spectrum. It's like a spectrum analyzer, and you perform a spectrum analysis, and then you check where the source of noise is entering with more intensity, and try to set your frequency or your band, depending on what you're using, outside of the source of noise. That is the only thing that you can do when you have this kind of, because other way will be lowering the gain and losing targets. And sometimes it cannot be avoided. In this case, you see that the noise is entering with very high intensity. It's not something that you will lower the gain and make it disappear. It's a very intense noise. And it suddenly disappears because sometimes we've seen sometimes it's not propeller nor gearbox, but it's this displacement noise because of the way the ship is presented, and the tilt angle. Sometimes it's the propeller, sometimes it's the engine, the gearbox. When the engine reaches some RPM, because they are trolling, and the engine reaches some RPM level, and noise suddenly, and they lower the RPM, and the noise disappears. This is very complicated to avoid, to eliminate. The only thing you can do is to move with your frequency and try to avoid it. Bubbles. Bubbles are enemies to sound, to ultrasound. The presence of air in touch of the resonant surface of the transducer creates a layer in which since the water is not in touch with the resonant surface of the transducer, in that moment, the energy from the transducer cannot be translated to the water. And in that moment, it creates an interruption. You see an interruption in the sounder, you will see something like this. It can happen to you when you are in a bad sea, very bad condition. That is a moment in all the fishing vessels come through the bad weather. They don't usually work in bad weather, but some vessels have this problem even with good weather. And when that happens, there's always a bad transducer location, and there's little to do with that. Little or nothing to do with that, other than change the location of the transducer, which is sadly only can be done with the ship in dry docks. So this is why it's extremely important to take the time, enough time to precisely locate the transducer to avoid this problem. because when the ship is working, then it's too late.
Comment maybe when we take the questions.
Go ahead.
Just related to how you actually mount the transducer, because say because of trim angles.
Yeah.
The transducer it's reading backwards.
Yeah.
Sorry. Then you will get air bubbles under it.
Yeah.
So it's better to have it in a steeper angle forward. So when both trims, it will
Yeah.
still be.
That
forward.
is true.
Yeah, that's.
It's you're making your very extreme angle, but
Yeah,
it's
yeah,
like a
exactly.
5 or 7 degrees sometimes, because when the hull is loaded, then the trim is changing. So it's yeah, your point is very important. Yeah, that's true. And but of course you have to be careful with that, because when you inclinate the transducer, you also are altering the depth reading, because you're inclinating the transducer, you're altering, sometimes you can alter the bottom reading, and that can create so you can trim the transducer, but you have to be careful that when the ship is operating, so to keep the right position, which is
That's true.
yeah. Sometimes bubble appear when the vessel is fully loaded or unloaded because of trim. Yeah. And this is the sad image of a bad decision. Double or false bottom. Sometimes an image of the bottom can appear like this. You see up here is a phantom image of the bottom can appear there. This is because you're transmitting with such energy that, and you're using a range setting that the bottom rebounds as many times as the pulse energy lasts. So when it rebounds so many times that it can see, you will see, if you increase the range, you will see all the rebounds down here. But if you decrease the range, rebounds will go all the way and will appear up. So to solve this problem, there are 2 ways, or 3 maybe. One way is increasing the range enough to the point you will not see anymore. Your double bottom will go down and you will not see it anymore. But that will cause a problem, because some fishermen don't want to increase the range because they don't see the fish, and then the system will downperform the ping rate. And okay, so one solution is to increase the range. The other solution is to decrease the ping rate. And the third solution, maybe, in our solder, is click the remove double bottom tool. What the remove double bottom does is it decreases the ping rate, but in a clever way. If you fix let's say you're fishing at 200 meters and you decrease the ping rate, you can put a fixed ping rate in the sounder. You select the ping rate, you put the fixed ping rate, you solve the double bottom. But then the vessel is going 150 meters, so the ping rate will be higher. But remember, you fixed it. So you don't perform the system fixing the pulse. You will not have double bottom anymore. But the system, by clicking this, the system will make the ping rate half of what the maximum could be at the moment. So if you're fishing 50 meters, you're not going to fix 1 pulse per second to avoid double bottom. You're using half of the ideal. Using half of the ideal, you will not see double bottom, and you will not downperform the system. So this tool is like cutting half the ping rate to the maximum ideal at every range. It's not like fixing the pulse rate. So you you fix the ping rate, it's okay if the bottom, if the bezel is working always same bottom, okay? If the bezel changes depths of working, then you're downperforming the system by fixing ping rate. Remember, ping rate is very important. As higher is the ping rate, the much opportunity that the transducer and the echosounder have to detect fish, especially when fish is disaggregated. So we don't want to downperform the system by fixing ping rate if it's not necessary. So we created this tool to remove the double button. When you have double button, you click on that, and what it will do, if you're fishing 100 meters, then the maximum pin rate will be 7.5. This will put 3.25. And but if you're going 50 meters is 15. Okay, this is the ideal. If you fix it, let's say you fix it three pings per second, here you could be doing 7. So if you fix it 3, you're done performing. So you keep the system, you click that, and the system will keep automatically half of the maximum ping rate to avoid double button and not to downperform more the system. Okay. Let's say you have a hardware problem in one channel of the sounder. That happened because of, I don't know, some problem or some failure. What you normally will see, or the calling from the skipper will be, if the skipper is using size measurement, the skipper will complain because he see no bars in the histogram, no average, no nothing, because one channel is not transmitting with the enough power, or is down performing. And remember that split beam needs 4 channels working evenly. So when this happens, you should have a warning from this system that the voltage in the transmitter is low. What happens is, the most common failure here is the high voltage power supply in the transmitter fails or stop working because an electrical failure in the power supply, the fuse is activated and the high voltage power supply is stopped working, and you don't have high voltage in the transmitter. So this is a very, not so very common, but happened before. So if you see that, that's a hardware issue. It's very easy to repair, but you will see the warning in the, when we discuss the hardware, we'll show you where is the fuse to replace for that. But that could happen. The high voltage power supply might be turned off because of a failure in the transmitting unit or excess of temperature also. Also because of temperature issues. This is where channel is low performing, but it could happen that there is no data from the channel. No information appears on the screen for one channel. And then if you encounter this failure, what you will like to do is to perform again the transducer testing that we will see the wizard during the setup process. There's a transducer testing done. you repeat the transducer testing, and the transducer testing will tell you if the transducer is the source of the failure, or maybe the channel is bad and there's a hardware issue in the equipment. So you have to, the advice here is try to repeat the transducer testing before thinking that the hardware is the problem. So, and in our sounder, you can check individual channels. So you will put the image, the layout of the screen in individual channels, and you will see a channel is missing, no transmitting or low performance, and then you will diagnose the failure easier. Sometimes with this system, they use a trackball as a source of control. Ballpoint may appear. You lose control of the pointer on the screen. This is easy. You go to the device manager and you disable the ballpoint. That's it. I don't know if you encountered this problem before. I guess you do. It's easy to remove. TCP/IP failures. Sometimes you see an indication on the screen that the TCP/IP connection interrupted, and that could be due to problems in the conflicts. If you have your sounder connected in an Ethernet network, IP conflicts may arise because other device might want to use the same IP or is programmed with the same IP. So check your IP definitions. And also we encounter some trouble. We solve it by using external protector to the connector TCP/IP. If you don't use that external protector that we provide, and you connect only the TCP/IP, sometimes it can happen that it has this movement and lose connection. Sometimes it's not. If you do the installation right and you put you are careful with the installation, it doesn't happen. But we provide a protector to the TCP/IP connector in order to avoid this movement can happen. But some technicians doesn't want to use that protector because they have to remove the connector and install the protector, and so we provide the cable, we provide the protector. We recommend to use it to avoid this problem. Sometimes you lose connection with the TCP/IP. Okay.
Main problem is mount.
Yeah. Until they made this metal bar and okay.
Yeah,
Your comment was that was a common problem with Marport also.
Yeah.
The thing is they make this a device in which you put all the cables and isolate the vibration from the.
They have a good protection on receiver.
Yeah, but in the computer.
And PoE. It's usually problem.
We don't have the problem in the computer, but we did have the problem in the black box. We've seen that we use very high quality connector. We use Amphenol connector to the black box, but sometimes it can happen that this movement can create an interruption in TCP/IP connection. So to be sure that doesn't happen, we provide a protector to the connector that isolates the possibility of moving that cable. So that is advisable to use. We had like 2 or 3 issues with this. Now it's not a very common problem, but it's very easy to solve. You put that protector and the problem is done. Well, we reached the lunchtime and first, if you have questions from here. Tom, any question?
No, not a question, just
okay.
it's this movable device that now starts to, once it starts to move.
Yeah, the ballpoint.
Mia. I found a few years ago, Norwegian company was making chart plotter called Telchart. Some of you might know it. They have this small program that you run that will disable the plug and play on the serial ports, and that's very simple. You just run it and it's done. And
That's a good one.
Yeah.
That's a good one. Yeah.
Yeah. So I have the link available if anyone
Yeah.
needs it.
Well, it's not something that but it happens. The ballpoints, it's a source of some service.
And if you're not there.
If you're not there, it's you have to be calling the skipper. You lose 1 hour explaining how to go to the control panel device manager and remove the ballpoint. So it's a good one. Your advice. It's I didn't know it, so we take note. If you wanna share it with everybody, I would appreciate that.
Yep.
Because I didn't know it.
I can send it for you, and you can maybe.
Thank you so
distribute
much.
it or something. So it's easier.
Is there any other question or comment, Oleg? We always appreciate your comments. Okay, we open the questions from the streaming.
Yes, they ask if you can explain again how can we reset the power fuse?
Okay. When I went through this slide, I was explaining that sometimes the battery chargers may want to overcharge the battery because the battery is not in good condition. It's trying to increase the voltage. So the maximum voltage that the CPU can handle is 30 volts. When the voltage goes over 30 volts, an electronic fuse will be activated. The electronic fuse is a part of hardware that we provide with the CPU. And this fuse, if it installed, it will activate when the voltage rises over 30 volts. When the fuse is activated, in normal condition, the fuse will have a green LED on. When the fuse is activated, no LED is on. So the fuse cuts the power and you lose that green LED. Okay? So that indicates that the fuse activated for any reason, any problem in the power supply, and then to reset the fuse, you have to remove the physical fuse that is in the line or disconnect the line from the power. So you disconnect the line from the power or remove the physical fuse. There is a physical fuse inside, and then it will reset. So the green light will be on, the power will be supplied to the CPU. But first, to do this, we recommend to check the power line because some problem causes the fuse to activate it. So we have to be sure that before connecting again the CPU, that we have the normal voltage that is good for the CPU. So the two ways to reset the fuse are removing the electronic fuse, are removing the physical fuse or disconnecting the line from the power directly, and then that provokes that the fuse is reset.
Okay, can we do something if we have cuts and we can see the bottom? there is some alternative?
That will be, I go back to the slide here. Well, when you have cuttings in the cuttings, I'm sorry, caused by bubbles, which is the source of the source of these cuttings here in the screen. There is little to do because there's a physical problem that is you are putting air in between the resonance of the transducer. The thing to do is to try to go through the transducer installation. I will recommend to use a diver if it's possible to check the transducer condition, because it may happen that the transducer installation may be damaged for some reason. Sometimes the vessel might went through a storm and the transducer might have damages, or the binder of the transducer might be damaged. And I will advise to use a diver to inspect the transducer. And if it's possible, try to repair it. But if the interruptions in the button are caused by a bad location of the transducer, which is the most common source of this failure, there is nothing to do other to change the location of the transducer. Sometimes changing the location of the transducer is possible to do with the ship in the water, because you have other transducer binders available in the ship, and you can easily switch the transducer from one to other binder. But if you don't have any other places to try with the transducer, then you will need to dry dock the ship and replace the transducer location with another that assures you that you're not going to have bubble. There is no other way. You can remember that we said that we recommended to have flanges in the binder. Sometimes the transducer binders are flangeless. Sometimes by only adding a flange, like this is the binder, you add a flange, and the flange will stop the bubble going down. But you can see this problem happening if it's a displacement bubble. It's a bubble caused by the displacement of the ship. Then you stop the ship, and if you stop seeing bubble, it may be the cause of the bubble is the displacement. Always the cause of the bubble is the displacement. But you may solve it by applying a flange sometimes. But some others, it's not that is a flange the problem. The problem is the location in the hull. So you can put any flange you want. The bubbles is down here already, so you cannot avoid. If the bubble is coming from up to down, then you put a flange, you avoid it. But if the bubbles are down because of a bad location of the transducer, there's little to do other than changing the transducer location. You have a comment, Tom?
Yeah, I have. Because you can have a good spot for the transducer. And
Yes.
everything works fine. And then you make a change to the hull.
Ah, yeah.
Yeah, and then you're kind of screwed. So it can.
Good point.
Yeah.
Good point. They
So
may alter.
You can have. I always ask, do you do when
Yeah.
someone asks me and get a problem? Did you do any changes to your?
Yeah, they change. Sometimes they change the sacrifice anodes, the one they use for corrosion.
Yes.
They change. They replace the position of these anodes and
They make a bulb.
yeah. They sometimes
Cluster.
they I don't know. Every time the ships go dry dock, you know how the ship goes dry dock, but when it comes back to dry docks, you never know, because nobody asked you before installing new things, is this going to affect the acoustics of the vessel? No, there's no asking any question. So they put new devices for I don't know, engine cooling. Every change that you make to the whole shape or the whole under the whole installation is a potential source of bubbles under the transducer. Good point. Even I saw a case in which the painting of the hole created bubble. That is something that blew my mind. But the painting on the hole changed it, the way the hole, I don't know, displaced the water, and by lowering the displacement of the water, created turbulences in the hole, and that created bubbles. That blew my mind. The painting in the hole. So remember, we are dealing with high precision devices. So these devices, whenever you alter the minimum parameter in the chip, you will notice in the echosounder. If you change, sometimes they replace the propeller. The propeller was bad, but was bad in a frequency, creating noise in a frequency that is out of the equipment range. Now the propeller is good, but it's creating a noise in a range that is getting into the. But the bubble, I'm afraid, is little to do when you have the problem. You first inspect the transducer, because it may happen that the transducer is broken or the binder is broken. But if the binder is okay and nothing is, and you still having the bubble problem, then I'm afraid the only way to solve it is to relocate the transducer.
Okay, and what's happening if I choose a transducer that is a small angle?
Yeah.
And the ship could move a lot. I can lose the bottom too.
Yes.
So it could be better choose a bigger angle.
That depends on the depth you're working. Definitely, if you're working high depth, then your footstep, the transducer's footstep, will be big enough to like in 400 meters, let's say there's a mathematical formula to calculate this, is the being angle. But in 400 meters, 50 meters, for a 7-degree angle transducer. So it's a very narrow transducer, but in 400 meters, you have a footstep of 55 meters, maybe. And then you will not have that problem. But then if you have a 7-degree transducer and you're working in 50 meters, you might have, with a very rolling ship, you might have that issue. So it will depend on the how deep you are working, and of course, if you choose to use a wide beam, that the thing we've been discussing before with Tom, you have a trade-off. You use a wider beam, of course, you will not lose the bottom because of rolling and pitching, but the loss because of absorption of the media that you have in higher frequency with wider beams, it will cause that you will lose sometimes the signal from fish. So if you care more from the bottom than from the fish, yeah, good. Look for the best solution to always keep looking at the bottom. But if you're looking for fish, be careful with the angle of the transducer, because you're trading off. Yeah. Is there any other question?
No.
Okay. Okay, lunch break. Okay. Before running the wizard, there are some things that you have to keep in mind, or you should short list as mind reminders. Black box Unix, all the system must be previously connected. Black box connected to the power supply and grounding. Black box connected to the transducer or transducers. CPU connected to the power supply and grounding, CPU and black box connected, and an NMEA line also connected to the CPU. So we have all the system wired. Power is on. Power is on, of course. And so we are ready. So the first screen we see when we start the wizard is welcome to the installation of the FMF series. Now, this is the stage 1 equipment detection. This will search for valid IPs. All black box has IPs preset in the black box. This will look for the existing equipment. You will see there, and this will identify which black box is connected and which one are you going to configure it. After you selected the black box, then this will show your selection. If I selected a 1000, this will show this. Here you are able to change parameters like the name. You can put their IMO number of the vessel. You can, if you think that you will have some conflict with other black box or other devices, you can switch and change the IP address of the system from there. It will show your system as you select it. Let's say you have 1000 with only 2 channels, because we don't do it very often, but you can order 1000 with 2 channels. It's got no point because you have 900, but maybe you have a special order and you can order a 1000 with 2 channels, then you will see blank space here and you will see only 2 channels, 1000. If it is a 900, you will see that. Stage 3 is licensing. You know, our product is sold with a basic license, the system working with CW pools. It will work in all the bandwidth, but it will work only in CW pools. If you want to use special features like biomass, like chirp mode, like roughness and hardness, temperature sensors, plus power, mixer, all of those are licenses that you can purchase separately. This we did it because in the past we offer like all the system in a package, but this is better for marketing because it's allowed you to offer different alternatives. It allows you to offer your client a system and then escalate in performance and tools as the client demands it. So here it will happen 2 things. If you have the sounder preset from us, all the licenses you have available will be checked because we already presetted the licenses and installed the licenses. But if not, you will have to go to every tool that you know your client has license to. You check the tool and you retrieve the license, which is a file. Okay, and you will configure all the licenses available. Stage 4 is where you configure the transducer. Now, here can happen that your transducer is one existing in the list. If it is one existing in the list, you select the transducer and the system will retrieve all the parameters that are stored in the list. That is a database with manufacturer parameters. So remember that we need to know the actual condition of the transducer. So anyway, we will have to go through the transducer test. You will set the parameters, factory parameters, but then you will have to check if the transducer actually is working according to manufacturer parameters. And that is even when the transducer is new, because it may happen, as I told you before, that you made a mistake in the connection of the transducer and the transducer will not behave as the manufacturer parameter. So we do the transducer checking anyway. So you select the transducer for channel 1, for channel 2. If the transducer is not in the list, let's say it's a transducer that you know for sure all the parameters from the manufacturer, and you want to use it, we always recommend to ask us before, because we might have some previous experience with the transducer, and if it's not in the list, it might mean something. It might mean that it's a very old transducer, maybe it's a transducer that is that is too old for this list, or maybe that is not advisable to use it. You can use it, but it's always good if you have the chance, contact us before selecting custom transducer, because and you need to have all the manufacturer parameters, because the system will require total power, transducer angle. So in order the system works fine, custom, you can add custom, but there's always, well, in this example, we selected the 599 LH, low and high. Is a typical installation of let's say a 900 system or 1000 with 2 channels. Stage 5 is, well, the system tells you, okay, you selected this transducer and this transducer. I see all the parameters. These are the parameters that the system has in the database. The total power, the central frequency, and the bandwidth are the parameters from the factory. So the system will retrieve the parameters from the factory. The yellow buttons tell us that the test for that channel is not made. So we click on the bottom and we make the test. Before we made the test, if we selected a custom transducer, the system will require to enter the parameters of the custom transducer. You see there, you need to know the beam angle, the central frequency, and the output power. And if it's a chirp transducer, it will ask the bandwidth, the beam angle, and total power, and the beam angle at the higher and the lower frequency, because it has different angles in the bandwidth. The same stage 5, after you click the yellow button, it will start transducer test. Now you see there. Don't be afraid of the graphics. The graphics are very simple. The one at the top measure voltage and the other amperage. And we only measure that for calculating impedance. So we calculate impedance and we see how impedance behaves on the bandwidth. You know that not a transducer, for example, the 599, they don't have the same impedance in all the bandwidth. So you have, like typically in the edges of the band, you have a higher impedance, and in the central frequency, you have a lower impedance. So it's always like a U-shaped curve. So in this case, with a little bounce in the middle there, but it typically is a U-shape. So the system will calculate the ideal power that it can deliver to the transducer to meet the impedance the system has. And we'll select in the next step always in stage 5. In the next step, it will adjust the power to the impedance that the system read. So the system says, okay, I have that impedance, I can increase voltage. There is a limit for the voltage that I can deploy because of my power supply. There's always a limit, or all echosounders has a limit in the power supply. Then I will, if you have the values from the Furuno and the 599, and from our sounder and 599, what is the maximum output power that, yeah, if you have it, we did research on how much power you can really get out of the 599 transducer, our sounder, and the Furuno sounder. So we have so actually, even when the transmitter is 3 kilowatts, and the transducer can absorb 3 kilowatts and can deliver 3 kilowatts, the impedance limits us on how much power that we can take out of the transducer, because the impedance is not a plain line. If the impedance will be like a plain line, then we can perfectly match. But since it's not a plain line, we have to apply a compromise solution, because we cannot meet power here. Remember that we want to do the same transmitting power in all the pulse length. So if we are doing all the bandwidth pulse length, then we will apply less power here and less power here because the impedance is higher. And then to meet the requirement, maybe we have to do this. So and apply a total power, which is not the idea. We do it. Furuno also does it, because Furuno doesn't get all the 3 kilowatts out of the 599 transducer. I will go later with that comparison. So after this testing is this one. This one will calculate we'll work with the bandwidth that you select, and then you apply the bandwidth, you select there, you select the central frequency, because it might be the case that you don't want to work with all the bandwidth, you only want to work with that portion of the bandwidth. So it will bring all the bandwidth that is available. You can select it, you can select the central frequency, and then you apply the values and you run the power test. When the power test is finished, the power test will deliver a result. And if the power test...
Okay, the power is about 2 kilowatts.
Yes.
If we suppose that the impedance is 100.
Okay. So 2 kilowatts in chirp for 100 ohms.
Yes.
Yes. Okay. But that's the ideal. Or that's the real.
This is the real.
Okay, that's the real. Okay. But
It's in the channel, the low channel.
the low channel.
Yes.
And
it's supposed that it has to be 3
3
kilowatts.
kilowatts. Yeah. From the 3 kilowatts, we can get 2. And Furuno, I guess they can get 1.
Sorry?
Furuno 1900.
Yes, this is Furuno.
Oh, this is Furuno. And where are we? Same value?
Yes.
Okay. And do you remember in high frequency?
Yes, 1.5.
1.5 out of 2. Okay. And we are both the same here.
Yes,
Okay.
but always it's supposed that the impedance is
100.
Yes.
Yeah, but the impedance is not 100.
No, we measure and it's about 167.
Okay. 160 or 170?
60 or 70.
Okay.
Yes.
Say 170. Okay. So we are not going to get 2 kilowatts because the impedance is not what the manufacturer says in the paper. even more. If you retrieve the acoustic data from ERMAR, you will have all the impedances in each frequency. And you will see they say theoretical central impedance is 100 ohms, but in each frequency, the impedance is like 300 ohms in 28, and it goes like in the central frequencies, it goes down to 140, 150. So it's like in average, it's 160 and 170. Huh?
You won't get the effect that you should have.
You will get the effect that you should have because you will get better result if you have a better transducer. But that's the transducer we have. We requested ERMA that if it's possible to improve this behavior, just to get a more flat curve, just don't have those losses caused by a difference of impedance. But the answer was no. Not with the existing technology, we cannot deliver the same impedance in all the bandwidth. We can have the same theoretical response because this is a wideband transducer, but the impedance is not the same. I can show you the acoustic papers from ERMAR. They will be very clear in the impedance in each point of the frequency.
It's related with the bandwidth. Okay, so
In the extremes, in the edges of the bandwidth.
It's connected with the phone too. If you watch the phone that we said before, the curve of impedance is similar to the phone. So you can see represented in the
If you see the phone curve, you will see that the impedance is the inverse of that.
exactly.
Okay. So in the figure of merit, you will see that in the edges, the figure of merit goes the performance of the transducer goes down in the points that the impedance is high. So there's no solution. There's nothing we can do in the echosounder to compensate this problem. It will be better if we have a better transducer, but when we requested to create a transducer with a more flat curve, they said, okay, we cannot make it with the technology that we have available today. It might be possible, but not yet. Okay. Once you finish the performance test, but I want to clarify this. This is going to happen. Let's say you have a Simrad echosounder running the 599 or Lawrence or Garmin or whatever echosounder runs the 599. It's going to be the same because it's same behavior. It's the same transducer. So the only way to get a better performance is by limiting the bandwidth. If you limit the bandwidth, the result will be better in impedance, but you will lose resolution. Remember that in chirp, resolution is directly related with the bandwidth. So as we shorten the bandwidth, we decrease our vertical resolution. So it's a trade-off, you know? In chirp, there is no point in having that so much output power. If you're gonna use the transducer in chirp mode, you will see this problem. If you're gonna use the transducer in CW and you will use it in only one frequency in the center, you will not have any trouble because you match perfectly the impedance. It's only one impedance to match. No problem. Even here, we can match impedance. No problem, but it's only one impedance. But the thing is, when you have to deal with different values of impedance in the same pulse, that will happen in chirp, not in CW. But the thing is, in chirp, we have another tool to increase power. That is pulse length, pulse duration. So if you can retrieve only 1.5 kilowatts out of this transducer, which is mostly what we can retrieve, we can retrieve a little more than Furuno. But if we can retrieve 1.5, remember that if we use 4 milliseconds, that will be like 4 times 1.5. Okay, so it's like a 6 like the same as applying 6 kilowatts in CW. Okay, what's something in your eyes there? So pulse length is multiplied by the output power. It's like if you're using 4 millisecond pulse by 1.5 kilowatt, it's time multiplied by power. Total energy is like 6 kilowatt. Not output power. Output power will be 1.5, but total effective energy will be like 6 kilowatt. Okay? Yeah. So there is no point, and we can do it we can also do it in CW, but the problem is that if you use 4 milliseconds in CW, then you will have a 4 meters, like the pulse width will be like this room, right? So there's no point. But in chirp, you use 8 milliseconds and the pulse width would still be 7 centimeters. So in chirp, we can increase power by increasing pulse duration. So there's no point in doing like 4 or 5 kilowatts chirp transducer. If you're using chirp, then if you're not using chirp and you're using CW and you're choosing one frequency in the bandwidth, then in that case, you will be able to retrieve 3 kilowatts from that particular frequency. So you will have your 3 kilowatts in one frequency. In chirp pulse, you will not have 3 kilowatts. Not with this sounder, not with Simrad sounder, not with any sounder that uses this transducer, not the 599. So this is very important because when the manufacturers specify the equipment, they say, okay, 3 kilowatts, and there's a star. Because you see 3 kilowatts, and there's a little star here. And you have to check this star here, and there's the explanation of this. So you're going to get 3 kilowatts at one point in the frequency. You're not going to get the 3 kilowatts in chirp mode. And the reason is physics. Not possible with that behavior in impedance. In the end, it's an antenna. An antenna can be a wideband antenna, but it's going to have its impedance in the edges. Okay? After you complete the transducer and the test is okay, 2 green buttons will appear, and you clear stage 5. Stage 6 is where you can tell the system if it's going to be synchronized with other device. If it's going to be synchronized with other device, it has to be physically connected to that device. Remember what we saw in the junction box? So the wire between one echosounder to the other echosounder must be connected, and then we choose trigger in, trigger out, and the type of synchronization that we want. Stage 7 is the serial port communication NMEA. We are working in a UDP connection for NMEA also, so this will be soon like also complemented with UDP connection for NMEA. So NMEA will enter not only from physical communication ports, but from UDP. But this is for older system that you have to connect NMEA. So here you see the port, and you can see all the
No, it's not only one. It's the amount of ports that the computer have.
Yeah.
Yes.
So you can, if you don't have the computer here. If you have many COM ports, you can configure different COM ports. There's only one there.
And you can.
But maybe you can connect, no, it's not connected to here, it's connected to the CPU. Let's say you're retrieving GPS data from the GPS, but having you need it from the compass, so you have two NMEA connections and you configure from two sources. Okay? This is, if you see, this screen here has a monitor there. That monitor, the small icon there, like a screen. This is a monitor that makes you allows you to see the data flowing without format and with the format of all the sentences in the. So you see if you're receiving data and raw data and with the architecture of the sentences. Well, this is a final stage, stage 8. This stage is not will not apply anything to the software. It's only to remind you that the computer has to be grounded. The black box is like a checklist. The black box, the individual UPS, the section of the wire, okay, any comments that you want to create. This will be all stored and we'll make a report of the setting up, and then you can store this report with your installation papers, and it will give you a hint of what happened when you were making the installation. And this final stage 9 will create a backup from all the installation process to reuse in the future in case of losing. So this is the wizard. So the most difficult part is the transducer. But the transducer testing is something that the equipment does. You have to understand what the equipment does, but you don't have to do anything because it's only selecting the transducer. And if the transducer test gives you results that are within the manufacturer parameters or normal parameters, transducer testing will end up with a good, okay result.
Okay, so it's important to remind that we test the transducer, but the part, the electrical part, no.
Yes.
Okay, so we can't measure or control what is the transference between the transducer to the water. So this is an important thing because if you want to explain.
Yeah, we measure the electrical connection with the transducer, but in order to measure the behavior of the transducer after the electrical wiring, then you should have an hydrophone on the other side and check the sound log of the transducer, like checking the transducer transmission with an hydrophone. The only thing that we can do is to check the wiring, that all the energy, we check that you don't have any electrical issues with the transducer, but we don't know if the transducer has some sector that is damaged. Maybe if it is water inside the transducer, you will see it because the impedance will vary. But if it's not an electrical issue, if it is a mechanical issue, let's say sometimes the transducer, after hours of using, this is the contact layer with the water. Here we have water. This used to be a flexible material like rubber or a special plastic material. This is the contact layer with the water, and this is where all the acoustic elements are sticked to. So you need to have direct contact between the water, this surface, and the acoustic elements. Here is the crystal in the middle. So if there is some air in between this and this, then in the transducer testing, you will not see it because this is mechanical problems. Let's say here you have this, and there's some air here. And this happened because the transducer is a mechanical part that always is expanding and contracting, and sometimes the rubber, okay, and the pocket of air can be here, or maybe water, because water gets inside because, I don't know, physical damage to the surface. Sometimes they paint the surface of the transducer, and then somebody realized that the transducer was painted by mistake, and they start with a scratch. And then what they do is they left that surface all open to the water porous, so the water leaks inside. Remember that transducer is always like, I don't know, in big ships, it could be like 3 meters down the water, 2.5 meters. So 2 atmospheres of pressure, so a little pore, small hole in the surface, all that pressure will put the water like a jet inside the transducer. And once the transducer receives water, it depends on, it's a matter of time that this transducer will die. It's electricity and water. Okay. So this ends the wizard. It wasn't supposed to have a Q&A here, but if you have a question before going to a different chapter, I will happy to hear from you. Any question?
I see. The testing. Yeah. Scale max power. Here is it for only this picture or 200 meters for what?
Can you explain that? This value here, the last one.
Yeah. Scale max power.
I'm gonna.
Yes. The transducer, for example, is 3 kilowatts. Okay, but when we in this part where this say power, this is auto. Okay, so we apply the power. It depends on
We're talking
the
about
range.
this. I don't have a laser point.
When you have in this case 200 meters, we apply the full power. But we have 100 meters.
Oh, yeah.
Okay, you apply a half, for example. Okay?
Yeah.
You can change.
It's for the auto power. Yeah.
You change the point in which you apply the full power.
Okay. Let's say you have 200 meters here. So the system will have an auto power adjustment. So that value means that, okay, let's make it 300 meters. Here you have the 200 meters line. So the power will be like, here is 50 meters, here is 100. So the system create a table for power adjustment. This is because when you are transmitting at 50 meters, you don't need 3 kilowatts. You only need 500 watts or 1 kilowatt maybe. So, so you create like a table for applying power. What you select in that value is the point in which you will apply the full power. The point in which the table ends. Thank you for remembering me because I didn't remember to clarify that. The other value, noise threshold, is a value that is there, but we don't use it anymore. It was supposed for you to apply that threshold of noise, but that value is in the software, and you can change it from the software. It will be removed from the wizard, so you don't mind it. The other is the bandwidth and the central frequency. And when you see auto power, you see here auto power, then you have to set the point in which you apply maximum power. Or maybe you want to apply always a fixed power. Let's say you want to apply 1 kilowatt because it might be the case that you don't know if that transducer, which is supposed to be like 3 kilowatt transducer, but you are not sure about the actual real condition of a minimum, not electrical condition, but mechanical condition. This. So if you apply full power to a transducer which is already damaged, then it might be the case that the damage will accelerate and you'll lose the transducer. Yeah. So it might be the case that if you suspect that your transducer is not in good shape, you might want to use less power. So that's the reason why we let the user to specify one output power. By default, that will be in auto mode. So if you don't force an output power, that will be always in auto. Okay?
Okay, another questions. They ask why we don't want to increase, or why shouldn't increase the pulse in CW, the pulse length.
Oh, because you lose vertical resolution.
Okay.
It's not that you don't want. It's I'm gonna do some acoustic basics. Let's see. So in chirp mode, the resolution is related with bandwidth. That is, okay? That is, the more bandwidth that I have, more frequencies that enter into my equation, the higher, this vertical resolution. When I say higher vertical resolution, I say the pulse width will be smaller. So I will have a smaller pulse, a smaller pulse. So I will be able to discriminate fish in the water column because I will retrieve separate echoes from this fish, When I'm in CW, on the other hand, my resolution, this physical height, this is a physical value, 7 centimeters, 5 centimeters, physical value. My resolution is related with the pulse length. Okay. So you say, okay, but then we make a short pulse and we can achieve the same resolution as chirp. Yes. But remember the equation of the total energy. So the total energy is a pulse times output power. So pulse times output power. So the total energy that you are deploying to the water with a short pulse is short energy, low energy. So your performance will go down. And then you say, okay, let's make a longer pulse to get more energy. But if you make a longer pulse, your resolution is directly related or inversely, related with the pulse length. So as you increase the pulse length, you decrease your resolution because you increase the size of the pulse length. And then in this case, it might happen that you have 3 fishes here. You see it in chirp, but same in CW will be a chunk. Okay? A chunk, a shoal. And maybe there's not a shoal there, but is the resolution of the pulse that is leading me to think that we have a shoal when we only have 3 echoes. Okay? So it's not possible to change or increase the pulse length in CW. We can do it, but if we do a 4 milliseconds, in chirp, we still have, if we don't change the bandwidth, we still have the same resolution. But if we do 4 milliseconds in CW, we have a vertical resolution that the pulse length will be like 3 meters. Okay?
Another question.
Yes.
How do I realize that the transducer have a problem or is in bad conditions with the transducer test?
Okay.
The impedance test. Sorry.
Do you want to explain it? It will be better than me. Here is the transducer, the impedance test.
Okay, in the first figure, okay, we have the voltage. In the second one is the current, okay, and as Carlos said, in the third is the impedance. But we have two images, two curves. One is white and the other is yellow. Okay,
Can you see it? One white and the other yellow here? They almost match each other in the image.
Okay, so if the curve white and yellow match is in the same position or is really close, it's okay at the transducer. And you can see that in the below the bottom start there, you have a name phase. Okay, this is the phase between the current and the voltage. So the transducer we recommend that number was between minus 20 and plus 20
Yeah.
degrees. Okay.
So this, in order to be normal, this value here must range in between minus 20 and positive 20. That's the
Okay.
Tolerance for phase and in impedance.
Okay, in another case, if this number is bigger, so the curves, white and yellow, they separate, okay, and that effect produce that when we deliver the power to the transducer, not the full power will be delivered to the transducer. Some part of that power reflects to us, okay, so and it means more heat for us.
Yeah.
And less power for the transducer.
Yeah.
So it's not the best option. Okay.
It's not a perfect matching in between the energy that I put in to the transducer and the energy that actually the transducer can convert into.
Okay, this is not a problem for the installation or the wires. It's just a problem for the transducer. So many transducers have that characteristics. So because of that, we have to check the list of the foam or the other characteristics like impedance to try to avoid that situation.
Simrad do the same thing. You have an impedance checker inside the sounder. You check the impedance. If it's a split in transducer, you can check the impedance in each quadrant. Same thing here. You can check impedance in each. If this is a split beam transducer, you should do the test 4 times because it's one test per channel. Is there another question?
No question.
From here?
One question on stage 6.
6.
Acoustic and synchronized.
Yeah.
I was wondering, because I've never done this, about this heads, rise and fall.
Oh, yeah. Emma? They rise and fall. You will explain it better than me.
Yeah.
The edge.
Okay, so in many
You want to draw here?
this is a rise, okay, and this is a fall. Some many equipment they have just one of them, okay. In this case, we have both, so we can use the trigger.
It's not a better one. It's for compatibility that we use both
Exactly.
rise and fall.
So
Some equipment are, I'm sorry, some equipment only have rise, and then you choose rise, and if you choose the wrong one, you will not synchronize, and you will see like
a double button.
A double
but
button
not
near
like
the
this
bottom.
one, but it's very close, and it's like 1 meter
Yeah.
over the other one.
Yeah. So you see like a perfect double button, one on the over the other one, and then you know that that means that the edge is not okay. So you select the other one, and you don't need to know the edge of the other equipment. You try this, and then you will see that the edge is. If you know it from the manual, it's better. You choose the right one, and then.
So if you have both, you choose one in both echosounders, so it's the same.
This is when you're in the same frequency.
Yeah, this is when you are in the. No, what
In general.
when
Yeah,
you are.
but the problem is when you're in the same frequency, right?
When you have to use the
Yeah.
yes, but we recommend use the hormones.
Yeah. But both equipment are sending, or is just one sending? Both. Okay.
Okay, is there any other question here or in the? Okay, so we will. Oh, if you just don't ask the question now and you remember later in the Q&A, then let me know. Okay. Remember that I mentioned that one of the improvements of this system is the user tool. The user tool is something that we created in the FMF family to make skippers and operators in general, first officers, possible to store all the settings value. This will store all the values in the system, even small adjustments in the histogram and values that you cursor lines, values that you adjusted in the histogram, species that you selected. So you can store that. Let's say you use shifted range, it will store the shifted range, the range of the bottom expander. It will store all the values of the settings in the echosounder. So when the user starts, it will create, when the system starts, it will create the first user out of the parameters that the user is setting. So the user starts operating the system, it will create the Seaman 1 user. The system will also create a factory restore point. It's in the upper side. That is not for the user to use, it's for the system to restore if it needs to. That is read-only for the system, protected, so the user cannot modify that user. So operator, I'm sorry, cannot modify the factory default user. It's like a restoration point. If you want to go back, I'm sorry, to factory default parameters, you go back to that user. But in the lower window, you will see all the users that the system is that the operators had created for the system with the date and time that the user was created. That is because sometimes you create a user and you want to go back in some moment in time because you want to go back to the settings that I had 3 months ago, for example. So you need to go back to that.
For each user.
For each user, okay? But it's up to you. That means that if you want to keep that settings and change it, you have to save it and create a new user. So you save it, you create a new user, you preserve that user, and that will be a point in time for you, okay? Maybe you want to use the time to go back. Some skippers use the the seasons and skipper use the geographical position. You will see now when you create the user, you can make comments to the user. And then, so you can see, well, this user I created when I went to Svalbard. I don't know, whatever. Okay? A clever Norwegian guy gave me these settings. I don't know. Everybody knows that Norwegian guys are very clever, so yeah. So when you create a new user, you see here, you can comment extra info, you can name the user, and you can also add a password to the user. So only you can operate that user and can modify. Because when you are operating the user, every change that you make to the user will be stored, remember. So the system is storing all the changes. So when you select a user, actually you are in the risk of modifying it. So if you want to preserve your user, you're the skipper and you don't want the first officer to change your settings, you put the password on it, and then if the first officer wants to use your user parameters, he will not be allowed unless he knows the password. So it's to protect your own settings. Okay?
Yeah.
What makes you such noise?
I'm just thinking, would it be better, because you don't have the option to copy?
Yeah, you do.
You do?
Yeah.
Okay.
Yeah, so you can apply selected use, you can rename, you can eliminate, and you can save the current user. And when you save the current user, you can save it with the same name, or you can save it with other name. So let's say you are going to make some changes to the equipment, and you are not sure if these changes will going to positively affect. You save the current user before making changes. You apply changes, and then if you change the name, you can store as many versions of your user as you want. Okay, so this tool is very powerful because you can use it either for, I don't know, storing personal users, or for storing like ways of fishing. Like I name a user, I don't know, bottom fishing. You can create whatever. It's up to you. And for us, as technicians, we can create like we end the configuration of the system, and we are working with the skipper and we fine tuning, and the skipper said, okay, now I'm good. We don't need to keep touching. You save the user and save another one, rename it, and you say, okay, we are saving this user for the future. In case you mix up and you mess with settings, you can go back to that one. So that's the this is, and when you start the system at startup, the system will allow you to select and apply selected user. If you have a password protected user, it will require the password. If you don't apply password, it will go to the default user and start with the default user. I don't know, I'm sorry, what is this? Import backup, maybe you? Okay.
Maybe in a moment, you want to incorporate some configurations for another ship. Like, okay, you have two ships, and they use the same transducer in general. Okay, you can copy the configuration and introducing that and create another
share users. Okay. So this is actually a progress bar This is the time that the system leaves you to select the user and apply the user. If you don't select the user, it will go with the one selected, and if you have the password, you will enter. If you don't, you bounce until you select the right one. Okay? So that's it for users. Do you have any question about users? Any comment? Okay. Now we will see, we will see that for a little bit of software running, because we have been talking a lot about theory and slides, and I know that the people wants to see the actual system running. I know you've been in the expo, but the people from the streaming didn't make it to the expo, so we wanted to, before entering the description of the hardware, we wanted to make a short trip into the software. Okay, can you see it or something? I'm afraid the light is not helping because it's a, yeah. Okay. I will increase the gain, so, okay. Luckily, people in the streaming is not having the same problem as us, because they are getting the signal directly. So, but here what we see is the graphic interface of the echosounder. This one is the FMF-1000. It's a chirp system running with a 1 kilowatt transducer in chirp mode. Frequencies ranging from 56 to 84 kilohertz. This particular acoustic survey was done in Norway, in the area of Ålesund. Is that the right pronunciation? Ålesund? Ålesund. And so this is a comparative trial that we made in cooperation with Marport. We did it in with a small boat, a fiberglass recreational boat. We put the transducers in one, we used 2 transducers. We put the transducers in a mobile installation, were not fixed in the hull. It's necessary to clarify that being a fiberglass boat, we didn't have a proper grounding for the equipment, and we experienced a lot of interference, not interference, but a lot of electrical noise coming from the engine, coming from the, and also coming especially from the inverters. We needed to use inverters in order to provide power to the screens, because the screens were 220, and but the equipment was running with batteries. At the beginning, our equipment was running also with the inverter, but then when we saw the inverter is we are getting too much noise from the inverter, we switched it directly to batteries, and we solved part of the noise problem. You cannot see here that effect, because that effect started to be seen at 600 meters because of the TVG. The TVG was at 600 meters was amplifying that electrical noise, and you can see it. If we show you 600 meters, you will see, you start seeing the, you will keep seeing echoes from fish, but the noise level from electrical source start to appear in 600 meters. So that happened in both systems, in Simrad and our system. It was a little worse in our system because we had an issue with the filters in the FPGA. We corrected the issue. It was an issue of the order we applied the filters in the FPGA. So the filter of Simrad was more effective for the noise. We inverted the order of the filters. We are getting the same output. So, so the same behavior we encounter for both the systems. I don't know if you can appreciate it here, but we are detecting we are detecting fish at 400 meters. We are measuring it. There's a lot of life here in the fjords. Mostly is cod and sight. 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 Sight is a fish like cod. The flesh is a little different, but it's not as tasty as cod. I've been informed that when they are big, they are not good for eating. They are good. Yeah, that's not true. Oh, I have a different opinion. The opinion from the Norwegians was like, when they are small, they're okay. Okay. So this site is, in this season, we made the trials. Not so much cod was there, but instead was this. But for our purpose, the acoustic response of sight and cod are very similar. Their structure is pretty much the same, so we expect to have a similar response in sound as the cod. So we have a lot of aggregations of fish here at this depth, 250 meters. We have a lot also at 400. We have some aggregations here. You see that when I move the area that I selected, you see here the system is not providing any average. This is because I have the cursors activated only to measure the area of my interest. So I fixed the area of my interest, which is where my species, the one I'm looking for, is there. Also, you see how I will explain the acoustic signature, right? You see how the acoustic signature changes. Okay, you see different curves here. If you go down here, you see? Okay, I will go back to that later. Well, the system has a very intuitive menu bar at the left. All icons guide you to the different adjustment. You can adjust gain, TVG. You can shift the range. You can adjust the range from the value, or you can adjust the range from the screen, directly positioning over the range, or you can, sorry, I have a delay because I'm remote. Okay, I can position here and adjust the range. Okay, and then if not, I want to adjust it from here, I can adjust it from here. Okay. I can select also auto range to the system to use automatic bottom detection and auto range. Our system also allows the operator to set a specific white line. By default, the white line is in auto mode. Everybody uses an auto mode, but sometimes it might happen that, especially for bottom fishers, for bottom fishermen, bottom trawlers, the bottom area is very important. So they wanna correctly, precisely discriminate the bottom area. It's not that something that, okay, we leave it automatically and let the system to decide for us. We want to decide. Sometimes the skippers, they want to adjust the white line in a way that they see this is the bottom expander, this is the bottom expander, and they adjust the white line in order to some part of the bottom gets into the bottom expander. Yeah, so this is not supposed to be a good adjustment, because the white line is where the system decides, or you tell the system that the bottom ends and the echogram begins. Okay? So the system will select, because it's an artificial intelligence system, it will select the ideal point for the white line. It will look for the ideal point for the white line. But then you can make your own selection by adjusting the white line, because you want to see, sometimes the fish is too tight to the bottom, and you know the bottom here is not pumpy, and you see a bottom like this, and then you see that. You see that, okay? For the system, there's no separation enough to consider this an echo. The system will consider this a part of the bottom. It cannot be discriminated from the bottom. But the fishermen look at this, and when they see this behavior, they must think, oh, okay, some fish might be here too tight to the bottom because I don't have enough resolution. I cannot discriminate, but this could be fish. That is why white line, we allow to easily adjust it. By default, auto mode, okay? You can also, from here, activate bottom expander, a mid-water expander. You can suspend the drawing of the white line. You can tell the system not to draw it. It will calculate it, but it will not draw it like a white line. You can change color palettes, different color palettes. Some of our color palettes, you know that color palettes are directly related with dynamic range. They all have a number of dBs that they cover, and they divide all that dynamic range in all that colors that the color scale has. So these color scales they use almost all the dynamic range that the system can deliver. From here, you can adjust the graph speed, 1 in 1, 1 in 2, 1 in 4, the traditional way. But also, you can switch to time. And you can tell the system to show you a specific time on screen. You can go 5 minutes, 10 minutes, 17 minutes, 20, 1 hour, whatever. The larger the number of minutes that you will select, the image will compress. You will lose information on screen, because the screen is the same size. You don't have you don't extend your monitor. So the monitor is the same size. You put in more information, more time on it, so the system will put less data on screen. Okay. So, and you can go back and then you can do that to one channel. Let's say you have 2 channels. You can do time in one channel and pings in another channel, or you can apply time in both channels, okay? Here, this button activates the playback control. Playback control is this tool here, you see? So this allows you to go back in time, okay? You go back in time. Okay? You move back. This we have blank because we don't have data here. And when you're not looking at the information that is coming, you see the fish loop, there's nothing there because we are in the past now. The light down there blinks red and green. It means that you are playing, you're in playback mode. Okay. So you go back because you forget to see something or you miss something, and you go back. And if you want to go back again, and then you touch this button and it takes you back to life. And this is good for some skippers. They miss something. Oh, I'm missing it. Easily go back without having, because the system has a history here. Okay, but the history players will close the sounder, will give you a menu with a date and time, and you can play the raw data at that period of time. But it will close your sounder. So that is not for you to use when you're fishing. It's when you're fishing, you want to use the playback.
How long time do you have a playback?
How long time you can have it on playback?
It depends on the range, because we save screens. Okay, so imagine if you have, I don't know, 100 meters, the range, okay, you have, I don't know, 7, 8 hours. If you have, I don't know, 400 meters, you have less, because, and it depends to the ping rate.
Yeah.
So it's more data, less time.
Because it's a fixed amount of memory, and how much time you can store there, it depends on how much data are you collecting from the water column.
But
It
you
will
have,
depend on the ping rate, it will depend on the range.
yes, but in general have hours, 4, 5, 7 hours.
It's good enough?
Yeah, just because I've had questions from fishermen around this.
Yeah, if you want to go like more back in time, like this is a tool for going a 1 hour back, or 15 minutes, or half an hour. If you want to go back in time, let's say 2 days ago or last night, maybe if it doesn't fit into the window of the playback, then I'm sorry, you use the history. But history is very easy. You touch the H button, put the date, the hour, and start reproducing. But sounder will keep working, but you will not see it because you're seeing the history file.
Relative memory. When people smoking.
Yeah. Yeah.
What is what?
I know the skipper is taking a nap, or is going to the bathroom or something. And then
That's the reason for the question, because if the skipper is sleeping and the first officer is in the wheelhouse.
I don't know.
5, 6 hours.
As Emmanuel says before, it depends on the depth that they are working. It could be like 5, 6, 7 hours. But that is something that because this is stored in the RAM memory. Okay, so in the end, if for you the users become a problem that we can store only that amount of hour, we can, by increasing the RAM memory, we have a limit, but we can improve that. It's not something that is like hardware that we cannot fix it. It's something that we can do. We created the tool. Now what we do is we create new tools. When we are creating tools, we have discussions between us, and then we ask some advisors that we have, and then we release the tool, and then we have the feedback from the users. And then when we receive the feedback from the users, we like to have this kind of feedback, like Tom said. Okay, if it's not enough for you, then it's no problem for me to create more playback space. It's not. We didn't want to create like a giant file in RAM memory that it has no point to be there. But if it's needed, then it's no problem. Then you can activate markers in the screen if you want. I don't know if you can see it. It's markers like in other echosounders. Now, because of the feedback of the skipper that is our technical advisor, we will add one variable line, horizontal line and vertical line, because the skipper uses it sometimes to make measurements in screen. They want to line like the BRM in the radar, you know, the variable ring meter, but in the echosounders. So it's no problem for us. We will include the variable range meter. So you have, I'm not going to do it because it's going to take time, but you have different layouts. You can change layout from one screen to 4 screens. If you are in dual beam, you will have one screen and the other two, you have the mix, and the other two, you have the echogram data. This window here, it gives you information of the point you put the pointer on. It will give you the latitude and longitude, speed, and of course the depth, the date, the value in dB, calibrated, the ping rate at that moment, and the pulse width that you were using, the cursor depth, and the beam diameter there. Also, look, at 400 and something, you have 56.3 meters with 7 degrees low. Then you have menu to adjust the pulse width. Then you can manually set a pulse by not in this menu. In this menu, you can select auto pulse, or you can select a fixed pulses that you can save previously in another menu. So then you come here and you select and you change pulses. I cannot change it here because it's a demo file. So in demo files, you can reprocess everything that other than raw data. Raw data, you cannot reprocess. The pulse width is given by the signal coming from the transducer. Here we have tools, zoom, temperature application where you can add a temperature sensor. Could be the sensor from the transducer, could be an external sensor. It will start storing all the temperature values. It will make a temperature graph. Bottom hardness and roughness. Okay. So here when you start bottom hardness and roughness, it's hard to see because this screen is not so good, but you see the graphic there. You see a tiny red ball. This uses the Roxanne method to measure hardness and roughness. And then as a difference from Roxanne, the screens, the squares in which establish these squares, red, green, blue, and yellow means rock, gravel, mud, and sand. It's an old system, very proven, but our system allows you to customize the squares. If you're good enough to take samples of the bottom and you are sure that you can correct the parameters of the system, you can customize the squares and you can tell this for your transducer. Remember, this is for your transducer. Down here, this is rock, this is sand, this is mud. Because,
We have the authorities have made, in some areas, they've made checkups on the bottom.
oh, so you have the job done.
Yeah, you can compare. You can use this.
Oh, that's fine. That's fine. So you have actually the bottom recognition is done before. Oh, that's
Some places.
yeah.
And then you can
Oh yeah. If that is so, you can adjust to the official information, and it will be as good as the official information. That's it. And so the other thing that happens in the screen is that this color bar here appears down here. It easily indicates that if it's rock, sand, mud, or whatever. It's just, you want to close this, you close this, and you have the indication down there. It's like in the Furuno echosounders, they have this very funny graphic. They put the picture of frogs, and so we decided that that was too much, and we use it instead of the 4 colors to identify the different type of buttons. You could open the noise application, but it's not available here because it's a demo. You will see both channels. If there are 2 channels, you will see both channels. You will see all the spectrum analysis. If it is only one split beam, you will see 4 channels, the spectrum analysis, 4 channel split beam. The biomass index, the bullshit index. Here you can select if you want to use the echogram or selection. If you use selection data, it will give you the reading of the biomass inside the selected area. I will do a tiny one, and you will see. You see how it changes when there's more fish aggregation. Of course, you can see it on screen, but sometimes you decided, you decided to hide some part of the under the game. There's some biomass there too. Okay, you don't see it on screen, but there's some biomass there too, because you lower the gain enough. Okay? This might be good for bottom fishing. Sometimes they lower the gain and they are not seeing the targets on screen, because remember that I told you that all the skippers they start like this. They start backwards because they start like this and they increase the gain until they think they see what they need. Then they stop here. And they say, okay, now I see what I need. I don't want to see anymore. Instead, what I do is I start here. Okay, I saturate my receiver. Yeah, I saturate. And I start going down. Why is that? Because this way, I'm sure I'm not losing anything. I'm deciding from all the information coming to the receiver what I'm going to choose to see. Sometimes the skippers miss information from the bottom. They set the game very low. And there's biomass there. There's not so much, but there's something. Okay? There's more biomass there. Okay? This could be a useful tool. It's not that the number means something particular that you can relate with kilograms or tons of food or fish. I'm sorry. It is. We are making an experiment. We will make an experiment with the skipper that he will record a catch, complete catch. He will store all the biomass of the expander of that complete catch, and he will try to relate the catch with the biomass and try to get to a conversion. But that conversion will be useful for him only, because you change the transducer and you change calibration and the value of the biomass will be different. The value of the biomass will be the same if you have same echosounder, same calibration, same transducer. Okay? And then there's the split bin menu. Here you activate the histogram. Here you activate, this sounder can export data to the EchoView software. The EchoView software is a software that scientific institutions use to process the information after, I don't know, fishing trips or research trips. From here, you can activate acoustic signature, fish position graphic, and the calibration tool. This is the calibration tool. You remember this? Okay. Calibration tool. Are you familiar with the calibration process of an echosounder? Have you ever been in a calibration? Well, a calibration is a process in which you use a known echo, a known target, a pattern target. You put it down in the water. You hang it using a fishing line, very thin line, because you don't want the line to be present in the echogram. So you use a thin line. You actually use 4 lines. You make like a little nest of lines. You use 4 lines. You have 4 guys with fishing rods, VHF, and you start doing like up and down, and you move the sphere up and down, and then you move the sphere up and down until you find the level you want, the depth you want. Then you move the sphere horizontally. You want to locate the sphere as close to the center as is possible. When you are in the center, the system will paint this in green, these 4 squares. Then you will tell the system is calibrated. But then you keep painting squares in green. You move the sphere through all. This is the sound log, the graphic representation of the sound. So you put the sphere here at the edges of the sound log, and you start painting all the squares. And when you paint it, what you think is enough, you take some spots in each quadrant. You store that process, and you compensated the transducer. So you calibrated the transducer, putting the sphere in the center, and you compensated the transducer, moving the sphere through all the sound log. It's a little word, but it's different, because calibration sets the total level of the sound log. Let's say this is the sound log. So calibration move up and down all the side log. Compensation creates the actual shape of the sound log by reading the value of the sphere in each point of the sound log. So the system stores it and creates a form that is made. It's like a drawing in 3D of the sound log. It stores it, and then if you find with the split bin, if you find a fish here, it knows exactly what compensation has to apply, because you previously compensated. Okay. This is a very complicated process. This is only easy in Norway. And this is because they have the fjords and these special conditions. They have very deep places with low or no current in some places. If you go to the part of the straits where the fjord is connecting to the sea, it's very strong current. But if you go to quiet places, you have no current. When you just put the sphere down, it's like a video game. But try to do this in other places. I tried, and it's a nightmare, because
the same strength of the signal in each direction.
No, yeah. You compensate in order to have the same, because if you measure the fish with the edges of the sound lobe, if you don't compensate, the system will tell the fish is smaller. The same thing. You measure here, the system will say it's big. You measure here, the system will say it's smaller. But you need to apply compensation. That is why split beam gives you the exact location of the target to apply the exact compensation. But if you don't have a calibrated transducer, then the compensation will be like, I don't know. Yes, I know the fish is here, but depends on the compensation value you set. All new transducers gets out of the factory calibrated. So you have the theoretical sound lobe. So you can calculate it, the system will calculate. Given the values of the angles of the transducer, the system will say, okay, this is, if all the elements inside the transducer are okay, all behaves the same, this is a perfect sound lobe. This is what you get when the transducer gets out of the factory. You don't calibrate, you don't do the sphere thing. But you have compensation. Let's say you use the transducer 20 years. Okay? We are installing sounders with transducers that have 20 years old. I don't know. Is that transducer going to behave the same way as it left the factory? I don't think so. So what will happen will be like, perhaps, I don't know, some elements here are not performing okay. Okay? And I don't know. I have a difference there. But the system will still think that the lobe is that. So I have error here, bias. Okay? Scientific vessels calibrate the sounder each survey trip. Every time they go out at sea, I don't know every scientific institution, but the most serious one, they put the vessel in an ideal location. They don't have the 4 guys with the rod. They have automatic electric winches. There's a guy inside commanding it with the joystick. They have dynamic positioning, so the ship stays whatever the current is. So the sphere is compensated. So they calibrate in 3 hours. They solve it. We did it the old way. We tried many places. We tried here in Galicia. We tried in Seattle, inside the Puget Sound, and we tried in Norway. The 3 places we tried, the best one was in Norway, and we did it in seconds. Like it was like a.
But can you do the same with time variable gain as well?
I'm sorry?
Can you kind of calibrate time variable gain as well?
Yeah.
You can do it with the same.
We don't do it, but it's possible. We apply like a model, which is the same model that Simra applies, which is the 40 and the 20 log time varied gain. But for calibrating time varied gain, you have to put that target as deep as you need. I mean, you need to put the target like, because time varied gain will express to the infinite. So you need to, if you want to calibrate time varied gain 400 meters, then you have to put the sphere 400 meters.
Yeah. I know, because I can see the anchor.
Oh yeah.
And it's not changing. So I know it's
Well, that's the same principle that with the sphere. Yeah, your anchor is your sphere, because your anchor is not changing.
no, exactly.
So if you see the same target in all the water column, then your time varied gain is fine.
And that needs to be correct.
That needs to be correct. Our system allows you to actually not only selecting 20 and 40, but you can select the values in the middle. So you can do 39 or 38 if you want. or 21.
So it's possible to automatically like compensate TVG.
It's possible for you to select different TVG curves other than 40 and 20. Automatically compensate TVG,
Not like this one.
not like this one, because this one is submerging a sphere 10 meters or 20 meters. For TVG, you have to do like your anchor. You have to go 400 meters down and then take samples of the sphere like every 5 meters, and then you will get your time right. We didn't do it because what we did is we verified with, actually you verify with fish, because it's just like when you get in target strength from fish and you see the same behavior, fish is our anchor, okay? But, so we know that TVG is good within ranges, but if you want to be like a more accurate in the TVG compensation, then you have, oh, what's that?
Yeah. So it's possible. That's good.
Yeah, it's possible, we don't do it.
No.
It's possible we don't do it. That will be my answer. This calibration ends up with a report. The process, you save the process, and that's with a report. It says, okay, your system is calibrated, and that all the people fine, happy, we go out to fish, and your measurement is now going to be more related with the actual status of the transducer. No fisherman that I know made ever a calibration in their life. Okay? They want the same performance. The geo stars in Norway, the best marine research vessel in the world, the geo stars, they want the same performance, but they don't want to calibrate because there's so much job to do. It's okay.
There's no time.
There's no gain with no pain. Yeah. And okay, here you have a menu. Settings, I'm sorry.
You forget it.
From here you can change units from fathoms to meters. That is what you have in all echosounders. You can apply filters. These are digital post-processing filters. These are not hardware filters. Remember, this is a chirp-ready sounder. So this is a receiver that is going to be open from 10 to 500 kilohertz. So these are digital filters. Remember that when we're using chirp, there is a filter, natural filter, which is a correlation. And then there are filters for interference, weak and strong, when we have interference from other acoustic devices, and we don't have proper synchronization, or we don't have synchronization at all because the skipper doesn't want to synchronize, or whatever. We have smoothing. Smoothing will apply some average to the image. It will smooth the sharp edges and will give you a, I don't know, better picture. Then you have noise filter, medium, weak or strong noise filter. And then you have a couple of thresholds that I will my engineer here to explain because I don't remember what they are.
Okay, the threshold is we use a converter from analog signals to digital signals. So this number is just a threshold about this conversion. Now we have to change this number and put in dBs.
Yeah, because it's in times, in counts.
Exactly, in times.
Yeah, it's for engineers, not for normal people. Normal people don't understand. They say times. No, I don't understand. I roughly understand dB, so it's for me. It's Okay, and there's also an expander threshold that you can apply this magic of removing the side lobe. So you can say, okay, I want to look like Furuno 1900. You put and you clean you have a clean bottom. You're not going to see anything, but you're not going to see the side lobe either. Okay. And then, from here you can activate indicators like, I'm going to close something because I have too much Teams open. So I have different indicators that white line is auto, gain is in 38, depth is in 400, temperature, the hardness, the value. This is similar to what Simrad does. It puts the value of the hardness at the bottom. When the system is calibrated, it should be right. Remember calibration? Okay. Remember, nobody does calibration? Okay. So in case of the gain, you can theoretically change it from here. I don't see it happening, but yeah. I have this delay. Okay.
I can move.
Okay, move it. Okay. You put the pointer on and you can change it from there. Also. You can adjust graphic speed from here also. And then you can move these indicators wherever you want, and you can change the size if you want to see a bigger depth indicator, I don't know. We've seen in some Visuals bottom controllers that they have the depth indicator like a big number. Here is the old guy, the transducer test. You remember? Because when you're not in Wizard, you can always do transducer test. You always can repeat the transducer test. You can do it as many times as you want. You can, from here, you can change. Let's say you have to replace a transducer, you replace it with a different transducer, the one you were using. So here is the process to select the new transducer and perform again the transducer testing. From here, from here I can select a new bandwidth. In the past, in our sounder, that meant that you have to repeat the transducer test. Now, since this new model, you can, since when the transducer does the transducer test, it stores all the values. Then if you change the bandwidth, you don't need to go through the test anymore because it has all the values stored from the first. If you replace the transducer, you have to do the transducer test again, so you have all the values stored. Okay. Here you select the up and down modulation of the pulse. You know that in FM pulse. Are you okay with temperature here? Because I think it's a little cold. Yeah, a little hot, I'm sorry. Hot. Are you okay? So, yes, modulation. So you have like, you can, in FM pulse looks like this. So it start compress, okay? Because there are different frequencies in one pulse. But you can modulate from a low frequency to a high frequency, or you can modulate it from a high frequency to a low frequency. And that's what you set here up, FM up or FMF down. By default, is FM up this way. You can select here bandwidth. Our system has the possibility to set up a transmission bandwidth and reception bandwidth separated. And this is very tricky. Let's say that you want to transmit maybe you want to transmit with this bandwidth, but then when you receive, you want to receive only this portion of the bandwidth. That could be because the pulse, when you use chirp frequencies, depending on the depth that you're going, perhaps the higher frequencies, you start losing it. So the pulse changes. So you're not receiving the same pulse you are transmitting. Okay? Do you get it, Tom? When you transmit a chirp pulse, you go from low to high frequency. If you go deep, this part of the transmitted pulse, when you receive it, you will start receiving it low level, because the deeper we go, the higher the frequency, the more absorption. So when we receive it, the pulse is not gonna exactly match the correlation. So sometimes you may want to stretch the reception of the transmitted pulse in order to adjust the behavior. Only take the part of the correlated pulse that you are going to use for better. Did you understand it?
Yeah, I understand what you said, but the speed of sound is slowed down with high frequency.
Oh, the speed of sound is constant. Yeah. Yeah, the speed of sound is constant, but you know the effect of the media absorption in higher frequencies. A pulse of sound in chirp will have elements in different frequencies. The higher the frequencies that elements are inside the chirp pulse, the more absorption loss they will get as the pulse goes down. So the pulse is not the same when it goes down. So you made this pulse here, and when it goes down, it starts losing, but it will lose first the higher frequencies. And when you received it, perhaps it will not match as good as if you're taking the portion of the transmitted pulse that is good, but because it didn't suffer a lot of absorption loss. I don't know if I'm making my point clear. So in order to have better correlation result, I may want, it's not mandatory, but I may want to transmit in this bandwidth and maybe receive in this bandwidth, and not use this part of the bandwidth because this is a higher frequency, and this will alter the result of the correlation. That is clear?
Yeah.
Not enough, I feel.
Yeah, I understand what you're saying.
You're just figuring out.
I'm trying to understand it.
If you need more explanation, we can go later deeper in this, because he has explained me many times, and it's clear when you do all the drawing in time and frequency, and you see how the echo is altered because of the absorption loss in the higher frequencies. Of course, you can do something to compensate that, but sometimes you don't want to because you don't need it.
You don't need it. Exactly.
Yeah. Okay.
Yeah. But this means you have to choose.
You don't have to choose. You can choose.
Yeah.
It's up to you. You can choose, or either you can use the same bandwidth for transmitting and receiving. Default is going to be the same. But if you want to improve the result of your correlation, just imagine a skipper doing this. They are like their minds is blowing out. You are doing this because you're looking at the result of the performance of the echosounder, and you see that something is not like the way it should be, and perhaps we can help you to diagnose a problem here, especially if you fish deep and you use, I don't know, higher frequency, but medium frequencies like 120, 130, and 90. Those components of frequency, when you go 400 meters, you start losing it. You still have your chirp pulse coming back. But if you can analyze the frequency content in that pulse, you will see that higher frequencies has lost importance compared with a lower frequency. So the resulting correlation, it will match, but it will give you a different result than the real result.
Yeah, but what I'm thinking is that this depends on what you really want to see.
It depends.
Because if you need to see the whole column, then
Yeah.
the high frequencies will be important as well.
Yeah.
Yeah.
But if you want to see only the first 100 meters, then there's no point in doing that because you will get all the scattering that you need.
I need both.
But if you need both, then you will have to make a sacrifice in order to improve your correlation results.
Because when, for instance, fishing with nets, we don't put them on flat bottom. Very rarely we put them in the hills, and you go towards and you see where the fish is. So you need both to see deep at the bottom and high up to gain the information you need.
Yeah. But in that case, you will lose some vertical resolution because you shorten your reception window, but you will improve the result of your correlation. So targets will be more real in that portion you decided to correlate. Am I right, engineer? You were not paying me attention. You were looking at the cell phone. Okay. Okay. And here you can switch in between modes, chirp and CW. That's the easiest menu. There are only two options. Here you can take a picture, a screenshot, then you go to this folder and you retrieve the screenshot. There's a menu here in which you can switch in between day and night mode. We have to improve that because we have yet some things that are, we improved the night mode. This is night mode and it is not night enough. I think we have to improve that. You adjust transparency here. And here you go to some general settings where you can adjust trigger. You can go to the task manager of the CPU. You can see communications, the same NMEA screen that you saw in the wizard, sorry. And that's it. If you have any question, here is the user menu and the history menu. Now it's in demo, so no history is available. The live, what is the name of the lifesaver? I don't know. Is the manual. So you just click there and you have the user manual. Nobody reads the manual, but so that's it with the echosounder.
Can Can you change, so go from night to day mode, can you change different background colors? And stuff?
Yeah, it should change. I don't know if it's working.
I have it on the screen here as well, but,
It should change from black to white. Then you can select the background color that you want. But the thing that I don't like from the night mode is that these separators in the menu still have a lot of bright. You cannot do anything with the echogram because the echogram is colorful and you cannot do anything. But we still can improve some. These edges here can be improved. So we will work on that. Okay. I think we cover. We will, if you want, we can make a short recess of 5 minutes, and then we come back and do a quick go through the hardware, and that will be it for today because we've been here for a long time. So I feel that you might be a little tired. So we'll stop for 5 minutes. I know that it wasn't in schedule, but I see the audience maybe needing to go to the bathroom and refresh, and we'll be back in 10 minutes, and we'll resume with some hardware information. Thank you. We will try to make it short as possible, given the amount of hours that you've been connected with us or here with us in the room. First, we have a description of the enclosure of the FMF-900. It's a single layer enclosure. In order to dismount the enclosure, you have to remove, I don't know if I can use a pointer, yes. Let's see. Okay, in order to remove this this tray here, this tray is the one in which the main board is attached. You have to remove only 4 screws from the back, and then all the layer goes out, and you can do service of to the 90% of the board. Only 4 screws. Am I right, Emmanuel? I don't like when we design enclosures. I always stress not to use more screws than we need. In order to open the Furuno 1900, you have to take out 23 screws. So remember that I told you that we started a service company. And we in our company has these drawers full of screws. Do you know where those screws came from? They came from equipment. So when technicians repair equipment, if they have like 16 screws, they put 12, because the other 4, they go to a drawer. And so in my echosounder, I want 4 screws. That's it. And so for you to access the main board, you remove these 4 screws at the edges of the heatsink in the back, and you will see all the echosounder from above. The only thing that you will not be able to see are these transistors that are covered with this metal piece that you will have to remove another 2 screws if the problem is there. So that's it. Then you can do service to the full echosounder without the cover. But even without the cover, you can run it, because you can run it while you see it in feed it and so the FMF-1000 has the same concept. You remove the the screws from the back and you throw away from the back. But in this case, you will be moving 2 layers at the same time. You remove 2 layers. You are going to be able to work, but you will have to put it vertically to see both sides, because otherwise. And pretty much that's the most important things to say about enclosure. Oh, enclosures are done in aluminum, marine grade aluminum. They are painted with a high resistant, temperature resistant, and scratches resistant epoxy paint, powder coat. So they should last. They won't last a screwdriver doing like this, but they should last the pass of time. This is the main board. One main board contains 2 channels. That is to say, one main board contains 2 echosounders, 2 complete echosounders, because they have a converter to analog to digital, a transmitter, a receiver, and a power supply. So that's one channel. And then you have the other channel, and 2 channels complete one main board. If you have an FMF-1000, normally will come with 2 of these boards. Yeah, they are connected, and they are synchronized because they transmit at the same time, because they need to be perfectly or close to perfection synchronized. Because when they transmit for split beam, remember that we measure phase deviation, so we need to be perfectly synchronized. They connect with the board that I will show you. It's like a backbone. It goes here in the heatsink. You cannot see it. It goes there, and you connect both layers with one. So the complete system is like one backbone card, the main board, and the front panel. So there's no more than that. If you have 2 layers, then you will have the same backbone, the other main board, and the other front panel. So there's not so many boards in the system. Also, easier to request for parts. The previous DBF-4000, it has, I guess, 8 DBF-4000, 8 boards. The four transceivers, the connection board, 5, the power supply board, 6, the front panel, 7 or 8 boards. This one is 1, 2, 3, 4, 5. The 900, 3. The thing is, we want to make it simple to give service to. If you order parts, you order the main board, that's it. If you want to repair the main board, it's repairable. Most of the things are easy to replace. So the things that maybe you will not be able to repair are FPGA or some complex part of the system, but even that you will see that you will kind of upgrade you will be able to upgrade the FPGA. So it's okay. We will start description of the architecture of the hardware. We have the transceiver power unit there that gives power to the transmitter and receiver. That is the transmitter unit. All the power transistors are there, the transformers. You see here in the screen, you see, I lose the pointer. Here it is. You see here in the screen these 3 relays here. This is a design from our own. This is like an antenna coupler what this does is that it adapts the impedance of the transducer to different layers in the transformer. So we have different layers inside the transformer. We design the transformer, we manufacture the transformer, it's our own design, and we do it by hand. Each transformer we test it. So transformers are very delicate in this equipment because remember that this equipment can operate in a wide range of impedance. So the transformer is very critical. This is the control unit, brain of the system in which all the data is collected, processes. Part of the correlation is done here. Then the conversion to analog to digital is done here. So yes. And then there is the receiver. Remember how many
Steps or
steps or branches has the receiver?
okay, we have two steps. One is to measure small signals about 1 microvolt to about 200 microvolts, and the other part is 200 microvolts to about 500 millivolts. Okay, you have two ranges. Then we have another part to measure the voltage on the transducer, and the other one we measure the current on the transducer. Both of them is to obtain the impedance that we watch in the last part.
Okay. So here you have in the main power supply, where the power comes from the out power source, you have the first input fuse. This will protect the system from damaging. Remember that you have an external fuse, but that external fuse is actually to protect other devices from our system. Yeah, because that external fuse will be activated once the equipment already has some problem. It will stop feeding the system. It will prevent the system keep damaging, but the damage is already done. We have a stage before that is this input fuse that prevents the damage. So there are two steps. The fuse, the normal external fuse, but there are internal fuse that they are quick, faster fuse. They react to problems in the power supply much faster than the external fuse. So in order to protect our hardware, these fuses they are gonna work previous than the external one. If the damage is strong enough to damage all these fuses and activate the main fuse, then there's no solution. But if you have like a small problem, then this fuse can save the equipment, and it's only a matter to replace one component and the system will resume working. This system has a standby power supply because the system has to be ready to activate it when the CPU commands start.
Yes. Okay, sorry. We have these fuses. Is one of two. We have a standby source. Okay, is to maintain the device ready to connect it with the DPC.
CPU, yeah.
Then we have fuses in every power supply. So if we have a problem with one power supply, this fuse disconnect the whole system, and you can continue operating with the other channel. In this case, for example,
all these fuses are minded to protect parts of the system from damage. Sometimes they can react, and we can save the system. Sometimes I think it's fast enough to. And so these actually are all nominal values for the all the different fuses that you have in the main board. So to make a summary of this, you have fuses in the power input, and then you have fuses in the transmitter units, and then you have fuses
In
in the
the
different power supplies within the system, the high voltage power supply,
and the standby power supply.
Yeah, and we also have a power supply, especially for the condensers, to keep the level of charge.
Yes.
But yeah, because it's to keep the condensator charged for the next. Yeah. This is a front panel board from backwards. If you turn it the other side, you will see the connectors, the thing that you see from outside. This is controls, this plugs to the main board and controls all the connectors from the transducer and the LAN connector. And this is the backbone. The backbone is this version is for FMF-1000 for 2 boards. There's also a version for 1 board, that is the one for, I don't have it here, but it's the one from the FMF-900, which is just the same, but only single connector. So the backbone boards have these LEDs that indicates, these LEDs here, up, indicates different status of the equipment, each channel, if channels are activated, power, and so indicates conditions and there are different situations. You can read the indicators and know if something is wrong with some part of the system from outside. And now, to finish the training session for today, and then saying thank you for supporting and for standing by this long training day. We will go through the upgrade process. Upgrade process is very simple. It's been simplified. In the past was more complicated. You can activate it by clicking on the trident in the screen, and this menu will appear. It will allow you to load an upgrade file and update. When you decide to update, you will open a window to select the file you downloaded, and it depends on what kind of installation you download. If it is a software and a firmware installation or software only, it will present you the options. Here, for an instance, we see that the user selected to only update the firmware. You see the firmware in the FPGA, and the other firmware is the LAN.
Sorry, the second one or the
first one?
No, the first one is the software.
No. I'm sorry. The second one in the
Okay,
current firmware version master file.
Okay, this is the firmware of the microprocessor.
Oh, the microprocessor, yeah. And the other one is the FPGA firmware. So there are 2 firmware. Actually, when you upgrade, it's advisable to upgrade everything because if there is a new version of firmware, then we will say it's a mandatory to upgrade the firmware, because software is sometimes optional if you don't want to change things, but firmware, it will be always mandatory, because when we change firmware, is that we discover some problems, some bug in the or sometimes maybe that we add some feature that it might be interesting. So firmware is always, so you select from here the things that you want to update. If you want to update the 3 things, you update the 3 things and you hit update here. It will give you information about the update process. It will end, and everybody's happy. System is updated. It will restart with the new version. And during the updating process, the system will store all the configuration files to keep all the configuration that the user's files, the configuration files, so the user will encounter everything the same way. What happens is if I add new features to the system, there will be configuration that the user didn't set because they are new. So that configurations are added to the configuration files, and they adopt default values. Then the user can also customize this new feature. Let's say I add new tool that you have to configure. That configuration will be added to the configuration files with default values. So the system will be running with the new configs, keeping all the user settings the way the user left it. So the upgrade process is very simplified. In the past was more complicated, but now we feel that we made an advance with the progress with this. No. No. It is not for actually for the user. It is for the technician or for us. Perhaps we are working and we don't want to, because we are trying some things, and this should be button for the user. The user should be clicking all the three, but we as technicians sometimes want to try things and want to keep all options that you want to select one. But for the user, there's no point in not upgrading the FPGA or the microchip because there are 90% bug corrections there. So it's not gonna be bad for the user to correct it. Okay. Well, that's where the process ends. Updates successfully, and then the system restarts. Okay. Q&A. Is there any question about hardware or the upgrade process? If you don't want to do it now because you're falling asleep, you can do it tomorrow and with your fresh mind, and then we can go back and review all the information about hardware with a cleaner mind if you want. But anyway, we will provide service manual. Service manual will contain all this information in the presentation. Not only that, but will contain all the testing points and all the values with the oscilloscope screens that you should read in the testing points for you to easily make the testings. And we'll also contain the troubleshooting that you saw here in the presentation, some other things that usually carry the service manual, like a specification on the different wires that we recommend to use with the system. The wires are mostly provided by us, but sometimes you have to replace Ethernet cable, or you have to splice the transducer line in order to do it in a proper way. The transducer cable we suggest, so that will be in the CPU requirements, the minimum and the recommended requirements for each system, and all the schematics of the board will be there. We are not hiding information company, so if you need information, if you are in a rush and you need to give service to the board, we will help you with technical information to give a proper service to the board. Oleg knows because we did it in Russia, and yes, and so we successfully gave service to vessels in Russia through the cooperation between the ERA services and our company. The guys in Russia were incredible. They were like hands-on, and it was a simple problem, man. Simple problems are sometimes complicated to solve. So it was a good cooperation. We try to give this information to all distributors. We don't hide because there's nothing to hide. If Simrad or Furuno wants to have our system, it's easy for them. They have it. So if there is no question in this streaming, okay, that will be end of day one. Thank you for coming today. I hope you don't scare and you will be back tomorrow. But first, I will see you, the ones that are here. I'm sorry about the people who is joining in streaming. The people here will join with us to a dinner this night. And so we see you tonight. I will send you the location and the time. It will be not so late today. Okay, thank you again. Yes, you can take your stuff, or you can, I don't know if you, can we leave it here? It's the room is gonna be closed. Okay, you can leave it here. Okay, thank you.